Welcome everybody. So on behalf of the Samskriti Foundation, I extend a very warm welcome to all the participants, chairpersons, paper presenters and other dignitaries. We are very happy to start the second day's proceedings, and this session is on Sanskrit, Indian knowledge systems and encryption. And we have a very illustrious person to chair this session. I call upon Dr. M.S. Vijayaraghavan, former Special Secretary and Technical Advisor, Prime Minister's Office, to kindly come on stage and be seated on the dais. I would like to give a brief introduction about this towering personality. Dr. M.S. Vijayaraghavan, an alumnus of IIT Madras, served in the Government of India for more than 37 years before demitting office as Special Secretary and Technical Advisor to the Prime Minister's Office in 2013. Dr. Vijayaraghavan firmly believes in evolving strategies built around one's own strength. His core strength is in institution building, policy and planning, and launching of major national programs with internal and external integration towards making India prosperous as well as secure. It's a matter of great honor that he was chosen by Dr. APJ Abdul Kalam, then scientific advisor to Defense Minister, to work with him directly in his office to network institutions by harnessing scientific potential existing in the various institutional mechanisms in the country. At the PMO, Dr. Vijayaraghavan was tasked to shape the country's national security through technological empowerment. He was a member of the high-level national committee formed by the DOT, Government of India in 1997, whose recommendation led to the opening of Internet in 1998. He was a member of the PM-appointed committee that in 2001 brought out the report India as Knowledge Superpower Strategy for Transformation, which was disseminated by the Union Planning Commission. In 2002, Dr. Vijayaraghavan was called to shape India's first military qualified semiconductor IC production house, called SITAR, as its founder chief executive officer. He is credited with piloting the introduction of subsection 70A in the amended Information Technology Act 2000 for protecting critical information infrastructure. He also established the National Critical Information Infrastructure Protection Center, NCHPC, for implementing this subsection. In executing these tasks, Dr. Vijayaraghavan has served in various capacities across diverse organizations and ministries, including serving on the boards of organizations such as subsidiaries of Reserve Bank of India. Presently, Dr. Vijayaraghavan mentors several startups and is on the governing body of several deemed universities. Apart from that, one very important aspect I would like to mention to the audience here is that he has been associated with our organization for the last 20 years. And in 2002, under the guidance of Professor Lakshmi Tatacharya, a unique encryption system called the Katapa system, later it was named as the Katapa system, based on the Katapayadi system of the Indian tradition, was devised. And Dr. Vijayaraghavan was instrumental in taking it to the defense establishment. And we had encoded a particular text and it was given to the defense establishment system, and they declared that it is robust and it's not breakable. So they directly adopted it at the level 2 of encryption. So it was Dr. Vijayaraghavan who was instrumental in making this happen. And even today, this system is being followed in the defense establishment, of course, with necessary modifications, etc. I extend a very warm welcome to Dr. Vijayaraghavan on behalf of Samskriti Foundation. And more than anything, he is a very down-to-earth person and always available to us for giving his expert advice anytime, anywhere. I once again welcome you on behalf of the organization. I next call upon Sri M.G. Narasimhan, who has devised a new or neo-new, I would like to say, because every time it's being uh, reinvented to suit the standards of time, etc. So I his we all know about him. Yesterday he presented another paper. So kindly add on this stage. And thirdly, we have another person, Sri Raghavendra Prasad, who will be presenting the paper. I request you to kindly come on stage. Currently Assistant Professor, Department of Information Science and Engineering, RVCE Bangalore, Sri Raghavendra Prasad has been teaching for 20 years. He has worked on research in applications of Vedic mathematics in digital systems by IAVM, Institute of Advanced Vedic Mathematics, UK. He has been Executive Committee member IEEE Bangalore Section, SSC Chair Year 2020, as well as SSC Co-Chair, Student Activities Committee, etc. He was awarded as a top performer of IEEE Bangalore Section during January to June 2020. I extend a very warm welcome on behalf of Sanskrit Foundation. Now I request Dr. Vijayaraghavan to kindly take over and conduct the session. Thank you.
Audible? Okay. Lakshminada Samarambam, Nada Yamuna Madhyamam, Asmatacharya Varyantam, Vande Guru Paramparam, Yonityachadapadam Padarukma Vyamo Hatatatidarani Tranega Menaga, Asmat Guru Bhagavatosya Dega Sindho, Ramanujasya Jarano Jaranam Prabharti. Good morning to all of you. Any program connected with Samskriti is for me homecoming. So, seeing old friends after a long time. Well, this session evokes a lot of memories, and with a few introductory remarks, I would like to give maximum time for the speakers so that they have come with a lot of preparations and want to share their excitement with you. So therefore, I'll be as brief as brevity requires in any sessions of this kind. So before I get into the subject, I thought I'll make some few introductory stuff like Sanskrit has both language and scientific value. While language aspects has been extensively brought out over time through poetic and Vedantic text, scientific aspects, though profusely dealt with, have not been researched that much and documented by present-day scientists. This could be perhaps, in my humble opinion, due to highly Western-centric scientific thoughts that has been fed to us through generations, not yesterday, day before yesterday, several generations. Even in my younger days, I used to hear that anything that is best has to come out from the Europe. Against this backdrop, I had a wonderful experience more than 20 years back with Professor Lakshmi-Tatacharya, who was running a Sanskrit academy. It is not that Professor Lakshmi-Tatacharya was very unique in running any Sanskrit academy. There are many Sanskrit academies. I had visited at least 6 or 7 universities, Sanskrit universities. But one thing which is common to these Sanskrit universities, which I found was missing in the academy which Professor Lakshmi-Tatacharya was heading, is that while all others were following a template of Nyaya Shastra, Tarka, all that, regular things, progressing on the languages as well as interpretation of Vedantic text and all that kind of new things, Here is a person who was trying to find, is there any scientific developments which are hidden inside the text which can be brought out. And mind you, the trigger was not government certainly, because I can tell you for sure that this trigger of Professor Lakshmi Tatachar is not through government. It is on his own, which is extremely rare. So this is one thing which I found in the Sanskrit Academy, which Professor Lakshmi Tatachar was heading, which attracted me. So I will come to that a little later. So, about the Sanskrit language, which has a scientific dimensions too, I want to illustrate few things like the Charaka Samhita, Ayurveda, Panini's text, Sushruta's work, and many more. They all deserve an in-depth study as any contemporary scientific propositions and thoughts. For instance, Dhanurveda, an Upaveda, considered to be an Upaveda, is rich with details for developing the sports of archery. Many attributes of this work is generally referred to sage Vishwamitra and dates back to 7th century BC. We are talking about 6 million before the birth of Christ. It is gratifying once again. You see how the genes play a very significant role. It is gratifying that Dr. M.A. Anand, an illustrious son of Professor Lakshmi Tatachar, has been extensively researching this treatise, collaborating with some of the best scientific minds present in the country, such as NITI, National Institute of Industrial Engineering, Sports Authority of India, etc. So I was very happy to connect Dr. Anand with these entities, who not only believed that the quintessence of knowledge can come outside the organization. Otherwise, generally it is felt that if knowledge doesn't exist within my organization, then that is neither a knowledge nor it doesn't exist. So I have to be very choosy about people and the organizations. Organization must be reputed enough to put the stamp of authority, and at the same time the individual who is a part of the organization should have a broad and open mind for such things. So it took some time, but looks like it is coasting, and Dr. Alvar would bear testimony to what I am telling. So one can keep mentioning such ancient Sanskrit works ad infinitum. With the current session focused on encryption and the enrichment this subject has received from Sanskrit, one cannot but mention briefly the pioneering work done by Professor Lakshmi Tatachar. 2 decades ago, Dr. Alvar mentioned just now, the Office of Principal Scientific Advisor to the Government of India supported a program in this subject with Professor Tatachar as the principal investigator and mentored by 2 well-known scientific names in the country. Professor M. Vidyasagar, Fellow of the Royal Society, who was at that time heading Center for Artificial Intelligence and Robotics, and Professor N. Balakrishnan, former Associate Director of Indian Institute of Science here. This program resulted in an encryption system which is a substitution cipher coded by Center for Artificial, that is CARE, and evaluated for its strength by both Indian Institute of Science and Scientific Application Group, SAG, of DRDO. This system has a reasonable strength and is in use with Home Ministry. One small correction for Dr. Alvar, it is not Defense Ministry, the Home Ministry. Such a cipher has been derived through a deep dive into Kadapayati Sankhya system of encryption, which is very ancient. If one asks a modern cryptologist anywhere across geography, which is the oldest cipher, she would invariably say Jefferson cipher, attributed to the 3rd President of the United States, Thomas Jefferson, which is due to his use of encryption in his letters with his friends. This was, mind you, in the 18th century. Compare it with our own, which are extremely ancient. It is interesting to note that during a slightly earlier period, in the 17th century, that is 100 years before, there is a Sanskrit work named Sri Raghava Yadavina, written by one Venkatacharya. It has 30 slokas telling the story of Raghava, which is Lord Rama, very briefly. Just 30 slokas, you read it, and it is a story of Lord Rama. But where is this Yadavinam coming? I don't think Rama is ever described as Yadava, but where is it coming? It is simply Raghava, but the title of the text is Raghava Yadavinam. Here is where the interesting thing comes. If these slokas are read in reverse, if you just read the things in reverse, letter by letter, it narrates an episode from the life of the Yadava king, Lord Krishna, and hence Yadavinam. Reverse. And when, mind you, Thomas Jefferson, 1801, whereas we are talking about 16th something. Venkatacharya lived in 1650, 1660. Somebody who is familiar with the history will be able to correct me. So, this is how we have, disseminated our own strength to the rest of the world. And it is not something in isolation. Similar works such as Sri Vidya literatures are commonly understood as encrypted. So the use of encryption in Sanskrit works dates back to the period of Rig Veda. Mind you, that's the oldest Veda, which is 3000 BC, 3rd millennium BC. Okay, even before all the Greek and the Latin, all the things people ever knew. We are talking about Egyptian civilization and the earlier one. For example, Saint Vedavyasa arranged Rigs and Samhitas into 10 books. Looking at just one of them, the number of Rigs in the 10 books in combination indicates the number of dates taken by the 5 planets, Mercury, Venus, Mars, Jupiter, and Saturn, to orbit around the Sun, both relative to Earth as well as relative to stars. Extraordinary. This has not happened by accident, mind you. It is a case of conscious encryption by sage Vedavyasa. Thus, every ancient Sanskrit text and treatise has to be studied on a mission mode, not I give some project and it takes off, and afterwards there is no utilization of that. See, the one which Professor Lakshmi Tatachar we had given is on a mission mode, end to end. You find out what is the algorithm, code the algorithm, check the strength of the encryption, and see that it is implemented. You see, end to end. This is the mission mode. So such a mission mode type of approach one needs if you are serious about, culling out what is hidden in our ancient, literatures and treatises. So that has to be studied in a mission mode for the gems of encryption hidden there. So with these words, I should first thank Samskriti Foundation for remembering me and giving me this opportunity to share the dais with you. And let me move on to the first speaker of the day, M.G. Narasimhan, my old friend. I'll give a very brief introduction about him before I hand over the floor to him. Whether you want to sit here or there, that's your choice. Sri M.G. Narasimhan is a result-driven, client-facing program manager and training manager whose core competency includes software project management, including project planning and control, risk management, software estimation, cost management, configuration management. He's also dealt in software engineering, team management, customer interaction, training programs management, and in depth technical flair. He has 40 plus years of progressive hands on IT experience on different platforms from mainframes to web technologies. He is a technical head at Samskriti Foundation. The title of his talk is going to be Indigenous Cryptographic System. Over to Narasimha.
So I'll start with a brief slideshow presentation and then I'll show you this demonstration. Excuse me, I'm slightly looking for my presentation. Yeah, as you wish. End of the presentation is the best. After I do a slideshow and a demo, then we can take questions and answers. So I'm going to talk about an ancient method of encryption that is available in Kalidasa's Megha Sandesha and in things like Chitrakavya and a very famous, recently famous work called Siribhu Valaya and all that. So this is based on an idea of having some kind of a grid or a matrix as we call it. And this is what we call in the modern parlance, it's called transpositional cipher. That is, in cryptography, we have plain text, which is the actual text to be read by or transmitted to an authorized recipient, and cipher text, which is a kind of transformation of the text, and then it is transmitted by means of agents who even if they open it and read the text, they will not know what it is because it has been scrambled. So it's called a transposition cipher. So this cryptography is a modern discipline. It is a mathematical discipline, and it is a craft of hiding or encrypting and revealing the messages to only the people who know certain things about the um, method used to encrypt. Sometimes an unauthorized recipient may not even know that it is encrypted. So, but that is called overt and covert encryption. Ours is called overt encryption. It is known that it is encrypted, but nobody knows how to crack the system, but because they do not have the key to deciphering the system. So this is very important in military defense, as you know, as Dr. Vijayaraghavan has just now stated how much it is important for us in confidentiality and security of our own internal and external communication. I want to demonstrate a simple and potentially complex method that was used by Indians in ancient times for such transactions. So we have two parties who are going to exchange texts, plain text, which will be sent as ciphertext and will be decrypted back as plain text, and the original text is read by the authorized recipient. So this can be modeled as a three-party transaction. Okay. Can you hear me now? I mean, is it clear enough for us? Is it? Okay. Now you can hear me? Yeah. So we model the encryption and decryption process as, can you hear me now? No problem. As a sender or an encryptor, an authorized receiver or a decryptor, and an unauthorized receptor or a snooper. So all three are going to get the encrypted message. I mean, one person is going to take something called a plain text. He or she is going to send it to the decryptor, but also the snooper or the unauthorized receiver receives the same ciphertext. That's the basic model. So the encryptor is going to use special knowledge, various methods, information structures, keys, etc., to encrypt the messages. He will work in cooperation with the decryptor. He is going to share partial or complete knowledge about the methods and information used to encrypt the messages. The decryptor uses complementary knowledge of methods, etc., to decrypt the messages. So the developer of this framework develops a matrix in which all those messages will be embedded, and he devises traversal paths, or bandhas as we call it, to traverse the matrix. This is the basic model. So a message will be encrypted using an encoded matrix, a bandha or a traversal path or regular curve through the matrix, a starting point or a cell for the traversal of the matrix, and an end point or an ending cell. So it's just this matrix or a grid, and in which there is a curve which has to be traversed by both the encryptor and the decryptor to get that particular hidden message. So the matrix is a field of an operation. It has something called cells or elements, and in each cell can be occupied by what is called a basic language. This is a kind of abstraction. Basically, we'll just put alphabets in it in the beginning. That is the English alphabet. But you can also have Sanskrit alphabet. You can have Unicode. You can even have binary messages and so on. So I call it a basic language element, and for English it will be an alphabet. For the Indian languages based on Sanskrit, it will be one of the 52 aksharas available. A lot more elements than is required by the language of communication is needed. So, for example, the matrix in English could contain a 10 to 10, which is a 100-cell structure. An example for a bandha is a triangular shape passing through the cells. You can have a circle, you can have an ellipse, you can have a sine wave, etc. This bandha is a mathematical function. It is translatable to an algorithm. It has to be digitized and computerized. So the rules of this system are: the paths are known completely by the encryptor and the decryptor. That is, all the bandhas are published, at least shared between the encryptor and the authorized decryptor. The cells in the matrix can contain a basic language element, which is an alphabet, or it can remain vacant. It can be an empty cell. These basic language elements can be repeated, and alphabet D can occur more than once in a cell. That is, it can be populated with a normal English language sentence or anything like that. A set of predefined bandhas will be part of our framework, which is the software. These traversal paths will be known completely by the encryptor and decryptor. That means they'll be sharing the algorithms, how to decrypt and how to encrypt and so on. So here there are four variables in the scheme. There is an encoded matrix, there is a traversal path, there is a starting point, and optionally the end point. All the four are part of the keys of the system. That is the size of the matrix, a number of bandhas that are there, the starting and ending point, where the actual hidden message is there, and so on. So the matrix will be constructed in such a way that all possible messages, that is, can be 100 messages if you want, they can have various bandhas in which they are encoded and put into the matrix. So the size of the matrix is not an issue, because nowadays it's very, very easy to construct big matrices. So the encryptor of the messages has to share the matrix, which will be sent as a plain text file, or a ciphertext file as it is called. And the bandha which was used to encrypt message 1, the bandha that was used to encrypt message 2, and so on. If there are about 10 messages, all the 10 messages can have 10 different bandhas in which they are encoded. Without these 4 shared elements, you cannot decrypt the text easily, even if you have powerful computing power. Suppose there are 4 variables like this. Let us say there is a 10 by 10 matrix. The number of starting points will be 10, and the number of bandhas can be, let us say, a dozen bandhas, and the number of endpoints is also as 100. So we will get 400 into number of bandhas into number of endpoints into number of starting points. We can have 4,56,000 permutations. So this many will have to be deciphered by an unauthorized decryptor. So it can be computationally difficult to do. This is the idea behind this whole system. So now, these are just some snapshots of the old system that I had. But now I'll go off to the demo. So this is my starting. What I'll do is, as I said, I'll create a matrix. I want to, actually here is where you type the plain text that is going to be converted to ciphertext and then moved into a text file. But what I have done is have got some pre-populated messages. This says this is the first message. First, I will create something like a 63 by 56 matrix or grid. Now I'll take this first message and I will hide it. I will hide it in a very plain way. Starting from 0, 0, I will just hide it in a line by line horizontal manner. So this is at the status bar. You can probably see that it says it's done well. I can actually show the current state of the matrix. If you might be able to see that there is a lot of null cells are there, but there is some message they're saying this is the first message. You might be able to see it. I'm not sure that you can see it very clearly, but it is there in some kind of a blue color here. Are you all able to see it? Can you make out that there is a message there? Anyway, I can show you that in how it looks here. It says this is the first message, and then everything else is unpopulated, not yet hidden with other messages. Now I'll take the second message and I will hide it using another bandha. Now I have to know exactly where to place it. I can go over to this matrix and see where I can place it. But I generally know where it will fit in well. So I'll put it under 26, 0. That is the x coordinate of 26 and the y coordinate of 0. Using this thing called Mukhabandha, which is another U-turn kind of a path. So I've successfully hidden the second message. Now I'll take the third message. I will hide it using a third bandha at 32, 032. I have to remember these things and I want to reveal it. So I'm going to take the third message and hide it here. Now actually if I show it, you may be able to see that there is one message going like this, and one message that is going like this vertically, and you may be able to see that there is a third message going diagonally here. I don't know how clear it is for you, but it is going here diagonally like that. So 3 messages are hidden in this. Can you switch off this light? So that maybe they'll be able to see how the thing is being, how the messages are being hidden in the grid. So the first message is hidden as just a horizontal line in the first row itself. I don't know whether somebody is able to do that there. But if I kind of say display this message, it will just show the message like this. First message is here, the second message starts and then it goes like that. And the third message is actually a diagonal that goes like this. Now you might say, this is very plain, anybody can see this, and it is not a very difficult thing to understand where the messages are. But when I'm going to convert it to a text file, I'm going to fill it with noise like this. When I fill it with noise, this is how it will become. So now it is very difficult to know where is what. First message, of course, you can see, but where is the second message? You can't see it easily. So when I export the file, it will go in this form. And then they import the file, they'll have to again put they have to know 4 things here. They have to know that the size of the matrix is 63 into 56. They have to know that the first message starts at 00 and is in the first bandha. They have to know the second message starts at 26.0 and it is in the second bandha. The third message starts at 0,32 and it is in the diagonal one. These 3 they have to know that there are 3 messages in this. So this is how the whole thing is. When I display, it shows this way, but when I fill it with noise and export it, it will actually be this way. This is how it will be finally exported. So perhaps you can see the hidden messages there, that the first message, this is the first message comes here, and this is the second message comes here. I don't know, is it clear or not? Can you see that there, the second message, vertically going down like that? And the third message is diagonally going down like here. It's going like this. Is it possible to see that, sir? Okay. So that is the basic thing. I've only done a very little demo, but actually I have about 4 or 5 bandhas, and these bandhas are something like this. So you can have sine waves like this. Not the entire sine wave, but whatever is possible to hide. You can use a sine wave, you can use a mathematical equation. You can use a sine wave, you can use a cosine wave, you can use a parabolic wave, and you can have this particular thing called a heart-shaped wave. All this can be put into the system. More and more mathematical formulas can be added for this kind of curves that will make those bandhas. And those bandhas, the size of the matrix and the starting and end point, they give quite a number of this thing, so that the cryptanalysis becomes difficult. That is the reverse process of unauthorized decipherment. That will become quite difficult. This is the basic systems. So now I can take questions. Yeah. Yeah. This is here, it is an alphabet. Each letter is in one cell. But you need not have each letter in one cell. You can have, for example, a word in one cell. You can have even what's called an image in one cell. You can have an audio in one cell, and so on. You can populate these cells with any kind of binary format. It need not be just an ASCII text or anything like that.
No, my question was pertaining to your observation. Yeah. It can be Sanskrit letters out of 54. Yeah. So that precisely I want a little bit explanation.
That is, in Sanskrit there are 55 alphabets, right?
Can you use the mic so that it's audible?
Yeah. So in Sanskrit, we say there are 55 alphabets. I, E are the vowels, swaras and the vyanjanas, 25 plus 8 semi-vowels plus the IE, which is about 12, I think. So together about 55 alphabets are there in Sanskrit, or all other Indian languages based on Sanskrit, all the mainstream Indian languages. So that is why I meant by one of the things is it is not only English alphabets that can be populated in this system. You can have Sanskrit, you can have Devanagari, you can have Kannada, you can have Gujarati, whatever alphabet you want to put into it, you can actually emulate. I'll actually show you how to do it in for Devanagari here. Just a moment. Let me remove this and then start one more. I'll put it in. I'll make a bigger matrix this time. And here I have some Devanagari, which is say Srimate Nigamantaraya, etc. I don't know whether you can see it easily. Okay. Yeah. So this I'll again embed using this thing. Now if I see show, you can see that it is hiding the Devanagari characters here. So that's possible. I can hide one more here of another second line of the shloka. And I can go hide it somewhere like that way. So that's hidden. If I show it now, and you can see that it is hidden again here in a second bandhan. So if I display it, it will show it is hidden like this. So it is not just English, it is also other languages. That's one. So basic language element means alphabet, binary format, images, audios, everything can be put into the system. That's the basic idea. So if you have audio files which you want to send, you chunk it into fragments, put it in this way and scramble it like this and send across the resulting audio file as a cipher audio. So nobody will be able to crack it easily. They have to assemble it together using the decipherment system. That's the idea. Thank you so much.
Yeah. I have one. How does it compare with the present encryption and decryption in terms of the public key and the private key, in terms of degree of difficulty of enhancement?
This is a shared key system. This is not this is what's called asymmetric. The public key, private key thing is a asymmetric system where the receiver's keys are different from the complementary to the encryptor's key. Here the keys have to be shared in some manner. That it's very simple to share the keys, but it is a transfer system based on shared keys. That's how it is.
In terms of a degree of difficulty, has it enhanced to substantially from the current state of the art?
Well, we have to do a lot of cryptanalysis and figure out the computational complexity of the cryptanalysis process by doing exhaustive search and things like that. That's why I gave a small indication here as to the number of combinations are possible even in a 10 by 10 matrix with 4 or 5 bandhas. You got about 5 lakhs per combinations. So that is pretty difficult even for a computer. It needs to be millions, but that's a size issue and a number of traversal paths issue. So you increase it, you will increase.
Yeah. You have perhaps the control in terms of enhancing the difficulty. The user has the possibility of enhancing the difficulty. Thank you.
It can be scaled up.
So to elaborate on what you said, to elaborate on what he said, see, he's also mixing noise. Okay, it is partly something like a steganography type of approach, where an image will have an information hidden there. The rest of the images, pixels, everything is a noise. The information will be a small, it will occupy a small space in the whole scheme of things. So unless we have a mechanism by which this noise is cancelled, then only we'll be in a position to retrieve the information. To that extent, you are further adding the complexity to that.
Yes.
So it's worth pursuing it to its logical end and seeing how this can be put to use in.
We have to do what's called industrial scaling of the system. That can be easily done. Thank you very much.
One more question. So is it a Katapadhyay technique, or just it is coming from other?
It is called Chitrakavya, and I would call it inspired by the Siribhuvalaya and the Chitrakavya system of 14th, 15th centuries, and from Kalidasa's Megha Sandesha.
So from where I got the reference of those details?
Where I got the idea?
Yes, no, from where the literature has been available, so that if I would like to study those things, then from where I
Yeah, I'll send you the links for that. It's one of them is called siribhuvalaya.org. That is a website which they're dedicated to deciphering this great thing called Siribhuvalaya. It's a 27 by 27 matrix with about 1,200 chakras and bandhas, where they say all the languages of the world is there, and Bhagavad Gita is there, Mahabharata is there, and Ramayana is there. Just like that Raghava Yadaviyam technique, they have put it into a 27 by 27 matrix. That's the claim. It's a 12th century or 13th century Jain work.
Okay. Thank you.
Siribhuvalaya.org. You can go to that. Yeah, we'll take questions.
I think there's enough time for the questions, and if there are no further questions, I should thank Narasimhan for such an excellent. Only request is that take it to the next level and implement it. We now move to the next presentation, which is comparative study of adders used in developing high-speed Vedic multipliers for VLSI applications. Very interesting. And this is going to be presented by Dr. S.G. Raghavendra Prasad. He's a professor in Department of Information Science and Engineering in RVC College. And Raghavendra Prasad has been teaching for about 20 years. He has worked on research in applications of Vedic mathematics in digital systems by Institute of Advanced Vedic Mathematics, United Kingdom. He has been an executive committee member, IEEE Bangalore section, SAC chair in the year 2020, as well as SAC co-chair, Students Activities Committee in the year 2019. He was awarded as a top performer of IEEE Bangalore section during the June 2020. Over to Shankar Prasad, Raghavendra Prasad. Sorry. Our session is supposed to complete by 11:45, 11:15, 11:30. So you have about 20 minutes, and to be fair, 10 minutes for question and answers. Over to you.
Shri Gurubhyo Namaha Hari Om. My respects from this place to my late parents and also all the stalwarts here. And thank you very much, sir, giving me an opportunity. And thank you, Dr. Alva, sir, and also Mangala ma'am from CDAC, who has motivated me to present a small work, which is a ABCD step. We are going in this direction here. My parents and also my father was he was headmaster, and also he was a mathematics teacher. From him, a basics of mathematics I was able to capture it. And the outline of my presentation is this. First is the moment we come to know that we hear Vedic mathematics. Some students who are in the 7th standard high school, or it may be some gimmicks also, people are going to think in this direction. That's okay. And also Vedic mathematics is not completely accepted as a from pure mathematicians also, although there are whatever the sutras, they can relate it to what generally we relate it to algebraic formulae like a plus b whole squared, a minus b whole squared, and x plus a into x plus b, all these formulae. But still, nevertheless, but it is throwing some light into easier computation. From that point of view, if you take a positive perspective of that, So first we will have a discussion related to Bharati Krishna Tirthaji's Vedic mathematics book, and then there are many methods are there for computation, and we have Abacus, Trachtenberg speed method, and Japanese method, Vedic mathematics, and all these are different ways. And then we look into what is called as pattern, and then problems. One problem we take up from also earlier mathematicians what they have done, and some papers are published in IEEE, Springer, and also the Science Direct, and so many others. So consolidated information we can have a look into that. Then how can we apply it to Vedic mathematics? Anybody have tried out in this direction in a way such that what is the advantage of using Vedic mathematics apart from simple calculations which motivate students in middle school and high school to do math problem crunching? Can we take up into the next level where we can use it in the processor level also? And then the last part of it will be some basic survey we have done. Being a student of information science and also mathematics, graph theory is a very, very important concept, and Hamiltonian cycle as well as and some professor, he was asking about Chitrakavya, 1 or 2 points we can also have a look into that. During the 12th century, 9th to 12th centuries, poets have played with these Chitrakavyas and all, and then related to interestingly what is related to chess also we can have a look into that, and then I am going to conclude this here. I was fortunate to undergo the course from Dr. Narendra Puri from IIT Roorkee, from Indian Institute of Vedic Sciences also, and it was a great insight into Vedic mathematical thinking also from that point of view. The moment we hear about Vedic mathematics, we just Google, and immediately we are going to get the picture of Sri Jagadguru Swami Bharati Krishna Tirtha Swamiji, and if we can go through that, it is described that he has done 7 postgraduates at a time at the age of 20 itself. So it is very marvelous, and also he has got a lot of insight into all these things here. And earlier his name was called as Venkataramanan. He worked under Gopal Krishna Gokhale in 1905 for national education movement and also South African Indian problems. However, his inclination towards Indian culture led him to the study of ancient Indian holy scripture, that is Adhyatma Vidya. And then he wrote a number of treatises and books on religion, science, mathematics, and world peace, and so many issues also he has written many books of that. And out of that, he named, that is, he has written, it is stated that 16 volumes of book he wrote, and over the period of time, these 16 volumes were lost. And when he went abroad, one of the students of him was very much interested, motivated, and also they came up, and also finally once these books were lost, once again he was able to recollect from his memory and he was able to write, and this is the standard book which is available, that is called as Vedic mathematics. But I will not go too much deep into the history of that, because I was able to get only 1 or 2 instances whether why it is called as Vedic, why Vedic word is used, and all the other things are there. But if you go slightly back to the history of this, there is a mention of, so we have got so many sutras are there, there are 16 sutras are there, and also 13 or 14 sub sutras we are going to call it here. So one of them we can have like Ekadikena Purvena, Ekanjunena Purvena, and also vertically crosswise, Urdhvatiri Ekbam, and all the methods are there. But if we go back to this mathematics in India from Vedic period, I have taken the slide from Professor M.D. Srinivas sir. So there is a mention of maybe another 500 years before. So in Buddhi Vilasini, so the commentary, that is Ganesha Devagna, discusses vertically and crosswise. That means to say maybe there is a slight relation, and we have to dig deep into that. So we want to go beyond what is called as when it was started and how he was able to consume all these, and also we can go ahead with that. And in the book Vedic Mathematics, it is mentioned that in Sthapatya Veda, in the Atharva Veda, in Sthapatya Veda, it is called as Maths of Engineering. All of them are decrypted, are available, and also Bharati Krishna Tirthaji was able to consolidate all of them in terms of only 16 sutras, and it is not related to only one of them. So it is possible a mix and match of so many sutras also, depending on the numbers also. It's a very, very important thing here. That means to say, on a particular data, we can apply different methods to get a solution. So this is a basic thing, we can have it here. And along with that, so there is Bhaskaracharya is also given. I was able to go through the presentations of Dr. Ramasubramaniam sir, and also I was able to get some of the insights into Bhaskaracharya's Leelavati Ganita, where different mathematical methods, particularly multiplication was given, which is relevant to whatever we are going to study in Vedic mathematics also. This is a slight back history, that means I can go up to 500 years. So we are not going to deep into that, only what is a computational thinking we want to go up further here. So we have seen, children will be going during the holidays for, this is what is called as the abacus. A very simple thing is, all the beads are there if you move upwards, and all the remaining beads we move downwards here. So each of the column will be having 4 beads, and the upper column will be having 1. So you present like at a midpoint, I'm going to have a, all of them I make it down. So each one, if I'm going to move it here, it is 1, 2, 3, 4. So I want to have 5 means I make all of them down. The upper part, the whatever the bead is there, I will make it down. So that is 5. Again 6, 7, 8, 9. 6, 7, 8, 9. So I want to make it as 10 means again I move both of them upwards here, and the next column I'm going to take it into this direction. It is resembles the mathematics whatever we are going to learn. Similarly, there is Stratzenberg, and also there is this is called as Japanese method also, where sticks are being used. The intersection of these points, we are going to count it here, and also we can add it. And also Vedic mathematics, these are different methods we are learning. Some of the sutras just I will tell, and also one particular example we can take, so that how we can do the computation of addition, multiplication, and also the squaring of the numbers here. So ekadikena purvena nikhilam navataha charavam dashataha urdhva tiryakbam, and all these 16 sutras are there, as well as we have sub sutras anurupena, and so many other things are there. So these are possible. It is not that this is only applicable to multiplication, division, or addition like that. We can use a mix and match of these in a way such that we can do the computation. So this is also stated, and also this is given here. Now coming back to this, why are you interested in Vedic mathematics here? We also learn things from patterns also. So whenever we see patterns here, so we observe so many things. It is okay, this is like this. So a simple example of, we can take an arithmetic progression also. So I can see there is a difference of 2, or maybe a geometric progression, and so many other things also we are able to see. In the whole world, we see the patterns in this whole world, in this environment. So we capture that, and also we always try comparing that with any other thing, what the newly thing which is coming here. Vedic mathematics also, it works in the similar fashion, where can I find out while doing a computation. In general, I am going to use the word computation, maybe addition, subtraction, multiplication, or division, from a processor perspective itself. From a higher level perspective, it is AI and machine learning algorithms. From a basic processor, or completely coming into the arithmetic logic unit, it is only a number crunching is going to happen in that direction here. So patterns or observations are organized into meaningful categories, and also even while teaching the students also, if this pattern it matches, then they can easily grasp up, and they are going to enjoy the computation of maybe multiplication and division. Similarly, a research is also going on, that is we have seen in 2020, that is number representation and arithmetic in the human brain also. It is presented by Professor Behrouz Farami, who has a stalwart in the digital era as well as the computer organization architecture. Human brain activity, when it is engaged in the arithmetic task, is directly linked to the general computational abilities of a subject. An understanding of such activities can lead not only to a smarter, more capable computers, but also practical strategies for improving the computational performance of the human beings. In the sense that if we are able to do a computation in a way such that how the number is represented in our brain, the similar passion, if we are able to adopt it to the processor also, we can also expect an increase in the performance of, and also a different way of doing computational mathematics here. One simple example I am going to take it here, so that we can get an insight into that, and we can have, there is a method. So there are different methods are there. It may look very simple, why only simple mathematics and all. Simply, if you are going to take a squaring of a number, a 14 squared is given. So the moment, if you have already learned the table, definitely I'm going to say 196 directly. That is lookup table I am going to take into consideration from the digital point of view. Otherwise, I want to do a multiplication, normal multiplication, 14 into 14. This is also possible. So one more is there, what is called as the Yavaduram Tavaduni Krita Vargancha Yojayita. So here we have got the numbers in a way such that the power of 10 squared, 10 cube, 10 to the power of 4. If the numbers are nearer to that it will be very, very easy for us to do the computation. A very simple example of 14 squared is how much it is greater, yavad unam. So I am going to take what is delta x. Maybe if it is more means I am going to add it here. If it is less means I am going to subtract. So 14 plus 4 and 4 squared. Since it is the near the base 10, I am going to consider from the Vedic mathematics point of view, only one digit can stay in the right hand side, that is 4 squared is equal to 16. I'll carry that one forward here. 14 plus 4 plus 1, it is equal to 196. I can write it like that here. So that means to say, by looking at the squaring of a number, I can pursue this as product of two same numbers, that is 14 into 14, or a squaring of a number here. I can identify a pattern, I can also find it in a different way. In the sense, I am having a same data, I can apply different methodologies. Also, this is one of the possibilities I can apply in the Vedic mathematical method. Now, based on this, it was possible for us to develop for the 8th standard students around 6 chapters which is there in the NCERT, so that when the students are learning the basic formula of a plus b whole squared, a minus b whole squared, x plus a into x plus b and all such things, what are the applications of this, they can directly apply in a way such that it is an extra fitting to whatever the regularly they are going to study mathematics. Can I do what is called as a computation in a faster way, so that it motivates any of the students who are not able to or who find maths difficult, also it is going to motivate them. Others, they can find out another way also for solving this. It is implemented also, and the teachers are trained in this direction in a way such that they are going to enhance the mathematical capability also in this direction. So this is related to the teaching learning process for motivating and also getting a excitement or insight into what is a slight thing related to Vedic mathematics. So what next here? We are more interested in processor related here, because lot of computation is happening there, and also we are going with AML, IoT and big data analytics happening. My processor is only this much, and we are facing the problem with what is called as a power, and the space of the IC is reducing, heat dissipation is more. If I am going to increase the speed of the processor, again it is not going to increase the speed of the computation, it is going to simply consume the power, and also it is not going to enhance my performance here. So therefore, there is a research which has happened from Illinois University. Whatever the processors we have built here, it is simply overbuilt for a particular purpose. Is it possible? So can we find out those are the logical spaces are there which are simply not used? A simple example of, if you are going to take my mobile, there are lot many applications I have loaded into my mobile. You just find out how many of them you are going to daily utilize. WhatsApp, phone call, or maybe sometimes for calculations. Many of them we are not going to utilize, and some of them simply loaded and also not utilized. In the similar fashion, whenever you come across a hardware also, so there is unnecessarily it is built up, but it is not utilized, it is simply consuming the power. Can we find out a way in which we can reduce logically and then also physically in terms of gates and other structures which are possible here? So now, from yesterday's discussion, it so happened, we are depending on all the computational process for Sanskrit and other things. We are going with what is called as the AML and all the other things here. So now, if we take into consideration from a processor perspective, whether you are going to look into video, audio or whatever, it is only a numbers for me. It is only a set of zeros and ones I want to consume, and also I have to compute here. So from a processor perspective, so it is only arithmetic is a very, very important thing where I can do computation faster in a minimal time, and also I am going to utilize the possibilities here. So there are so many other points are also there. We can see there is a great development which has happened in terms of, so instead of increasing a speed of the processor, can I split up into quad core, octa core, and all the other cores are also there. Again, there is another problem is also there, and once again there is a block is also possible here. So that means to say that, so there are other things are there. That means neural networks, it is going to need, especially currently popular deep neural networks is limited by the hardware capability also here. So hence, these are the problems which are associated where the upper layer, applications layer, we want to have a huge computation, but my hardware may not support it, or I have to increase it in terms of hardware also. So hence, can we perform something here? So we slightly observe that Vedic mathematics is giving some pattern of computation. Can I see here, is there any such possibility? Can I find out a way in which I can do a computation still better than with the existing system, or with a small module I can introduce in a way such that I can enhance the computation here? So when we look into that, in the recent, there is a regular conference on Arith is a regular conference which will be happening, where all the people who are working from past 70 years and also from Intel and all the companies, so they are coming and also they are presenting. So now they have already come up with a new number system also, because we are finding very, very difficult to represent a floating point number which is consuming 32 bits of places here. Can we come up with another notation? Already there is a presentation has been done from 2017 and processor have been built up which is called as a POSIT notation, in a way such that can we represent with 4 bits both integer and also floating point numbers, 6 bits, 8 bits, in a way such that whatever the next era of computation is happening in terms of edge computing or any of the computing also, is it possible? When you look into that direction here, there is a great what is called as a requirement of working towards what is called as the arithmetic logic unit, in a way such that it is possible to crunch the numbers in a faster way. So let us go ahead here, and a recent presentation from integer multiplication from what is called as n squared to it has come up to the n log n also. It is presented in the 2022 year. So further go ahead. Anybody have they worked out in this particular direction here? So here we see that Dr. G. Suresh Babu, he is a HOD in the Department of Electrical Engineering from Hyderabad. So he has worked on 8051 microcontroller, where he was able to compute in a way such that a multiplication can be done, and also 15 times faster it is possible here. This is, I am writing a program, but the inbuilt hardware is the same thing what is already there in the 8051. So that means to say that by application layer, I am not able to reduce the time. Can we go depth into the hardware layer? Yes, sir. So there are something called as Puri Sir has imported Vedic mathematics and other things also there. So that means to say we have to come out with what is called as is there any model which can be applied for the Vedic mathematics? So we can go further here. So we know directly we cannot apply to the decimal number. So I have to go with a hexadecimal number here. So whatever the numbers which are there here, a simple example if you want to take, 9 is the highest digit in the decimal system and F is the highest digit in the hexadecimal system. Is it possible whatever the multiplication I am going to do with what is called as the Ekadikena Purvena and Ekanyunena Purvena, I multiply 6 into 9 is 54, subtract 1 from 6 and also 9 minus 5 I am going to get 4. Can I apply the same thing to 4 into F? So F is 15 and also 4 I am going to multiply so that I can reduce, that is 4 minus 1 I am going to make 3, then F is 15, 15 minus 3 I am going to write, it is equal to 12 which is equal to C. That means to say that if we think of these things in a way such that can I implement, so all these whatever stated in the Vedic mathematics, it is possible to do the crunching in the what is called as the hexadecimal also. That means to say we are slightly nearing towards what is happening inside the processor also. But what is happening in the current scenario, one we have tried out in our RV College of Engineering, one of my friend who is working in the electronics department, he has tried out different ways of doing addition and also the multiplication. There are so many multipliers are also there. So in that, one of them we have implemented in a way such that we built a 2x2 cross Vedic multiplier and further 64-bit 64 Vedic multiplier and compared with so many other different multiplication where carry skip adder, carry look ahead adder and also carry select adder, we found that the delay is only 6.576 or 6.968 compared to the Karastuba multiplication which is 28.2 nanoseconds it has come. So almost it is reduced to 1/3 of what is the time which is being taken here. But still we have not addressed what is called as a pattern based computation. It is almost same as what is happening in the general method of multiplication. So my presentation is here. So can we add somewhere here inside the processor where directly when you are giving it to the multiplication, I am going to add one more module into that in a way such that, so when you want to do what is called as the when you want to compare and also find out what is the pattern in that, so I have to do what is called as a comparison. I am going to do it here because usually any of the computation which is going to happen multiplication, it is only the shift and add method is going to happen here. So along with shift and add method, can I have an array of what is called as the comparators? I identify each of the nibbles which are there so that I am able to find out, assume that there is a 8 by 8 that is the 8-bit and 8-bit. I can easily find out what are the patterns are there. So by just looking into the pattern, I can easily fill up what is called as a 1 nibble and also 2 nibble here. So it is going to open up in a way such that, so from long years, Only the computation which was pending, that is called as the multiple instruction single data, was not operated here. It remained as a theoretical thing, and mostly from now onwards we may have to think in a way such that, because data is very, very important for us, can we find out what is inside of the data, and can I find out a solution from that? From this point of view, we can easily go ahead with that here. I think time is up, sir. Another. Can I have 2 more minutes? Yes. This is one point of it where we can go ahead with what is called as the arithmetic logic unit. This is one proposition. So other one is being a computer science student, N-Queen's problem, Rook's polynomial, Knight's tour problem, it plays a very, very important role. There is a relation between whatever the Hamiltonian cycle, can we establish it in a way such that it brings challenges to the students also here. So when we go with this, so there are Uttama Kavya, Madhyama Kavya, and also Adama Kavya we are going to have it here. So in case of Adama Kavya, we have got which is called the Chitra Kavya, we are going to get it here. So here we have got from Kalidasa, Raghuvamsha, from Kumar, that is the Janaki Harana and all these. Along with that, we found that is Vedanta Deshikar. So he has done Paduka Sahasram. So we were able to, it's already there in the Google. So it is not a work of us. We have just found out, and we tried out exploring in a way such that for a computer science student, can he go to Sanskrit and also do something here in a way such that he is interested, maybe encryption, decryption, and also we can go ahead. So in this, we have got so many other Chitra Kavyas we have got. One is called as the Jalabandha, Sarvato Badra, Ardha Brahmana, Turaga Pata, Ratapada Pata, and all these are there. So out of this, one of them is a very, very important thing, where in one of the shlokas, it is mentioned that, and it is directly relates to this, one of the shlokas which is given by Vedanta Deshikan sir. So this is a it's already available. So we are going to take this 32 words into in the 4 lines of the key in the chessboard here. So then place your knight in the leftmost corner and let it take a different path here. But it has to do a Hamiltonian path, Hamiltonian cycle it has to go. So when you take all these words, it becomes a combinatorial problem there. But still, if he follows the rules of Sanskrit to formation of a statement and all such things, we are going to get back one more shloka also, which again prays God that whatever the sins I am going to do, please forgive me and all such things. If such things which have been happened in the 9th century to 12th century, if we are able to bring it to our students who are in the current era, so definitely they will be interested to explore this, and also they can go ahead in a further direction. This is one, and also one more is there from the Kavya Alankara, like that is we are going to have. So we can have the same thing, we are going to get the same shloka also, we are going to get it like this. Yeah. So these are a small findings, we are going to have it here. So from this, I am going to acknowledge Dr. Shankar Rajaraman, who was doing the research in this. He has guided in this particular direction of all the bandhas we are going to have, and also some of the colleagues of ours, we worked in this direction, mathematics department, electronics, and also the information science. We are working together in a way such that can we bring out some value system in terms of Sanskrit and also computation and in terms of mathematics also. This is a small presentation. Thank you very much, sir, for giving a great opportunity for me.
The floor is open for questions.
Yes,
sir. Your slide 47 used a word,
yes,
Vedic sir. Digital research.
Yeah.
Right?
Yes, sir. Yes, sir.
Can you tell me more on that? Because almost every illustration that you worked out used a Roman alphabet system notation. Either it is the chessboard or the other things. But the use of Roman alphabet system as a notation was not the convention either in Vedanta Deshika or the earlier Chitrakavyas. So have you made experiment with the numeric notation for the Devanagari Aksharas?
For Roman, we have not tried out, and also I have not gone depth into the history of this also. But when we observe this, so if we consider since 0 existed and also 0 to 9, the numbers were existed, we assume that yes, it may be possible, and Roman numerals cannot be taken into consideration. And you are telling about Vedic digital research, sir. One more point. Yes, sir. So Vedic digital research, we can think like, can we do the computation, whatever there in the Vedic mathematics, which is proposed in this, can we compute using the hexadecimal also is the small point I wanted to bring it, sir.
Yeah. So I'm just giving an update information.
Yeah.
There is somebody in Hyderabad who has worked on what is called the Sankhya system. Some of you may know about that.
Yeah.
Dr. Gopi Kumar Bulsu. We are in team with that. The Samskriti code for such computation has been done with the system on chip SoC model, and details we can discuss outside. Thank you.
Yes, sir.
One more question, sir.
Yeah.
In some slide, you just mentioned the comparison of your multiplication and Karastuba product.
Yeah.
So what was the range for that product you compare? It
So
was how big integers you multiply?
No, this is, I have taken this work, one who is working in the electronics department, we attended a conference.
Okay.
So he was working in this direction in multiplication. So incidentally, I found that I was working in these systems in a abstract and also a modeling point, and he came up with a paper which he has been presented. So that he has in the simulation he has done that in the simulation, and also he used 3 different methods of addition. Also he has utilized that, and there is a comparison also he has done, and also all the it was there. Only I removed it because of the time constraint. So one of them I just took it, and also this I can just show you that also.
Yes.
This is So he has done with his name is Arun Kumar.
My question is just what was the range? It means how big integer you tried for these 2 multiplication?
No, I am not, because I was into only this theoretical part of it. I did.
Okay, I will connect you and then get the details.
Yes, sir. Okay. And this paper is also available, sir.
Okay.
This is the one he has tried out with Spartan, and also Xilinx he has tried out here.
Okay.
And he came up with this is a table which is available. So I was more interested in is there a reduction in the time taken in the
computation? Yes, actually Karastuba is the product is actually using in cryptography and everything for integer products.
Fine.
So that's why I'm asking that what was the range you are using for that?
Okay. I can find out.
Thank you.
Sir.
One last question, sir. Have you been able to do anything on the energy consumption of each
No.
like multiplication and addition and things?
Yes, I have done a survey of this because in the processor these are the things which somewhere some compromise is going to happen. Either I have to compromise with the what is called as the power supply, I'm going to compromise, or I have to compromise with maybe the space, or maybe not utilizing the resources properly here.
So good idea to compare energy consumption.
Yes, sir. Yes, sir.
Traditional as well as Vedic mathematics.
Yes, sir.
If you imagine a Vedic mathematic chip, would it consume less energy than a traditional VLSI? Yes,
sir. So this is the theoretical model. I have just started my recent research into implementation of this investigations on applications of Vedic mathematics into producing a arithmetic logic unit, where more of a comparison I am going to take in terms of what is called as a patterns. Can we do, suppose I want to multiply 2 numbers, let us say 8-bit itself. So I can take these 4 nibbles. That means I do at one stretch, if 4 parallel comparators are there, I can take it here. Once I know about this data, so automatically one part of the data, maybe a nibble or a byte, can be easily found out. The other part may be a subtraction of that or any other thing. So mostly at least 40% of the time consumption will be reduced. Is a theoretical thought process I have got. I have to experiment in this direction and have to go further.
Any other questions? I have a question.
Yes, sir.
It's a useful thing to compare the energy consumption.
Yeah.
But for the given real estate in a chip, the speed at which a computation takes place between a conventional approach and the Vedic approach, that also can be compared.
Definitely, sir.
Okay, that is one.
Yeah.
And second thing is, you also talked during your presentation in the first part on identification of a pattern.
Yeah.
Now, if you extend that identification of pattern, don't you think that you will be able to get into the field of cryptology?
Definitely. Yes,
because this session is on cryptology, so I'm forced to, make you think in those lines.
Yes, sir.
Okay, and then you have all the power and all the real estate at your command.
Yeah.
So it should not be a difficult exercise if you can slightly extend the whole approach to cryptology.
Yes, sir. Yes, sir.
Yeah.
Definitely, in a typical 8051 microcontroller, when we are going to take, one comparison is one machine cycle generally we take, and further now the latest.
Don't feel shy about the
Yes,
8051. I will tell you something.
Yeah.
See, right here in Bangalore, way back in 1998, okay, we were discussing about what is the best, controller, processor for our Prithvi and Agni, this one, the missiles. Oh, everybody, so those are the times we are talking about Pentium and all that.
Yes.
Whereas we are like 80, 81, 80, 85, type of things. Okay. To cut the long story short, today, there is a very ajib, very strange situation where we have to stockpile 80, 85 processors because that itself was able to do much of my, most of my requirement, and all because I'm able to simplify the software portion, the control software portion.
Yes.
As a result, the efficiency is improved, and then the real estate, I don't have to have the real estate which luxurious Pentium is able to provide. All those kind of things.
Yes.
So even today, that is able to run for the money, mind you, how many, 40 years or 35 years, whatever. So, such things are the ones. See, I'm not a great fan of Intel or this one. They drive and then we follow the things. Why not we drive? That's the system. If you think that this has a point, why the whole efforts, whether it is civil or military or whatever efforts, is driven by your type of things. Okay, which means essentially what I'm trying to tell you is, why not we play by our strength, build ourselves with our strength rather than our weakness.
Okay. Yes, sir.
That's my.
Thank you, sir. Thank you.
So we had a wonderful session. Two speakers, one of whom I am very familiar, and the other one I'm getting to know more. So they expounded on how ancient and the modern can be bridged effortlessly and with the minimum amount of resources. When I say resources, I mean financial resources and the technical resources that is available right now. So it was a wonderful session that we had, and encryption has always been an enigma, wrapped up in confusion and all that kind of things. But it is an area which requires a lot of attention, particularly when the present government is launching on Digital India, and then everything is becoming digital. Everything is becoming digital, and I don't have to tell you about how today a street vendor is in a position to transact without the cash type of this one. So to that extent, it has become a commodity. Digital has become a commodity. So along with that, see, anything there is a price to pay. So therefore, the price that we have to pay is in the form of somebody trying to put that into bad use, which means essentially we're talking about the vulnerability, and that is where encryption, other things come in handy. So therefore, the time is now ripe for putting more efforts into encryption, and I find that probably at the end of the day in the panel discussion you have someone from SETS who is also will be participating, I'm sure. So they will be able to throw more light, and thank you very much for giving me an opportunity, and it's wonderful to be with the Samskriti Foundation once again. Thank you.
So it's our privilege to have stalwarts like Dr. M.S. Vijayaraghavan, who piloted the encryption program long ago, nearly 25 years ago, as part of his being associated with Dr. APJ Abdul Kalam at a very high level. And today, as he said, it has watered down to the street vendors who will have a small QR code, and just we scan the QR code and we'll be able to make the payments. In fact, as you all know, I'm not an information technologist, but as a user of information technology, I can say now even the invitation that we have prepared for this event, we have a QR code, so you just scan the QR code and you get the invitation and all the details, and also the location of the place where we are having this program. So we are greatly privileged to have Dr. M.S. Vijayaraghavan. As I said, we have been associated with him from 1996, and I remember as a younger person, he visited Melkote once, and he was the first person to support something based on Sanskrit and encryption as long back as 1996. And that is how the association started. And he was instrumental, and he was the founder of the Sitar institution that works under the Ministry of Information Technology. And of course, he has handled more than projects worth 25,000 crores, etc., as part of the advisor to PMO, etc. So that way, our conference is a small conference for him, and he has condescended to our level and our request, and I'm extremely thankful to him. I am also extremely thankful to MG Narasimhan, who has been the backbone of all the technology aspects of Samskriti Foundation. He continues to do so. As I said, he has worked in all the areas of this, where we are having focal areas of this conference, like NLP, encryption, speech synthesis, speech technology, etc. That way, his contribution is mammoth. So we are trying to bring to light all the contributions in due course with the association and guidance of people like Dr. Vijayaraghavan. So I thank you, MD Narasimhanji, and also Sri S.S. Raghavendra Prasad, who hails from a traditional family. And many a times when we have people from traditional families, they actually, when they study modern subjects, there is an inherent weakness to compare and contrast tradition and modernity. And Dr. Raghavendra Prasad is one such exponent of where we can bridge the gulf between the past and present. That was what Professor Lakshmi Tatacharya used to say. My roots are in the past, I am in the present, and I work for the future. That's what he used to say. And we hope that motto is carried forward. So thank you very much to all the panelists, and thank you for the audience, very active participation. I now take the opportunity to honor the guests on the dais. And after this, we have a tea break, and we assemble here exactly at 11:45. Thank you very much. So first, I will take the opportunity to honor the guests, and then we conclude the session. So we now break for tea and assemble back here at 11:45.
remove it. Oh, no, I need to load the presentation. This is not with my computer. Oh. So I had a demo and all that. Oh, okay, okay. So you put on. Okay, okay. Thank you, sir.
Thank you very much.
No problem. I just wanted to load the presentation.
Please, Ranga,
No, no problem. No problem.
you can load it there itself.
Sure. ஃபைல் கொடுத்தா ப்ரெசென்ட் பண்ணலாம். ஃபைல் இருக்கிறதா
வேற சுரங்கள்லாம் வராது மொத்தத்தில் இதுலேருந்தே ரன் பண்ணலாம்.
பின்னாலே சேஞ்ச் பண்ணணும்.
இதேமே இருக்காது. ஓஹோ ನೀವು ಇದೇನ ನೀವು ட்ரை பண்ண கேட்டுக்கணும் ಹಾಗಿದ್ದೀರಿ. ಯು ಆರ್ ಇನ್ ಚಾರ್ಜ್ ನೋ.
Welcome back, everybody. we are starting the session on Sanskrit and other ICT tools. This session will be chaired by Sri Ramesh Srinivas Raghavan. Currently, I request Sri Ramesh Srinivas Raghavan to kindly come on stage. Currently, Principal Product Manager Sri Ramesh has contributed at Adobe in various roles in the last 15 years, including engineering roles, technical evangelism, research, and now product management. Prior to that, he has served as head of research at Aztec Soft, where he worked with several startups as well as in various software engineering roles at HCL Pero. He was senior project officer at the knowledge-based computer system labs, IIT Madras, for about 3 years. He has also worked closely with stalwart Sanskrit scholars as a consultant. His interests include knowledge-based systems, AI, computational linguistics, and Indian classical music. I extend a very warm welcome to Sri Ramesh Srinivas Raghavan. I also extend a warm welcome to Sri Nitin Nagaraj. Kindly come on stage, sir. I also invite Dr. R.C. Sarita from CDAC Bangalore. Kindly come on stage. First of all, I would like to introduce one of the greatest scholars, contemporary scholars in Vedic and Vedantic Shastras, Vedavaridhi P. Ramanujam. Dr. Ramanujam is ex-associate director CDAC Bangalore and founder trustee Sri Parankushachar Institute of Vedic Studies, Bangalore. He established the Indian Heritage and Language Computing Center in CDAC. Earlier, he worked at HAL and Kirloskar in Electric Company. He earned his MSc Engineering from Indian Institute of Science as well as DLIT from Sri Lal Bahadur Shastri Rashtriya Sanskrit Vidyapeeth. He is also trained in the Gurukula system and has learnt various scriptures such as Vedas, Vedantas, etc. from his revered father Sri Parankushacharya and other great stalwart scholars in those days. In fact, he was the first person to be an outstanding Vedic scholar and also an outstanding technocrat. So we have several technocrats who know little about Vedanta or Vedas, and several Vedanta or Veda scholars who know little bit about technology. But our revered Dr. Ramanujam sir was the first to scale the heights of both Vedanta, Veda as well as technology. And he was one of the pioneers in bringing together Sanskrit and computers. In fact, in 1993, he was invited by the then Prime Minister, Dr. Mr. Narasimha Rao, to prove that Sanskrit can contribute to computational linguistics, not the other way. And he did it successfully. And even now, he is very much active in bringing together technology as well as our Vedic literature and Vedic Shastras in various dimensions, like whether it is language technology or Vedas, markers for the Vedic accents, etc., etc. In fact, even I am not able to fathom the entire gamut of contributions that he has done to Veda and Vedanta. So he will be presenting his paper on ICT tools and Vedic processing along with a demo. The second speaker is Dr. Nitin Nagaraj, currently Associate Professor at NIAS, National Institute of Advanced Studies, where we are holding this program. He is in the Consciousness Studies program. Once again, this program is also a very unique program because, as I said, consciousness has been one of the areas of great expertise of our sages of yore. And yesterday we have had a session on AI and consciousness itself. Sri Nitin has earlier worked as lead scientist in GE Global Research and as a postdoctoral fellow at City University of Hong Kong. His research interests lie in brain-inspired artificial intelligence, causality and consciousness, and Indian knowledge systems. Today he is going to talk about are IKS still relevant in today's world. I extend a very warm welcome to him also. And Dr. R.C. Sarita, Joint Director CDAC Bangalore, has earned her PhD from Sri Padmavati Mahila Vishwavidyalayam, Tirupati. She has 15 years of R&D experience in CDAC, Kumara Park, Bangalore, and she has been awarded Scotch 2018 Award for Marcel Project as well as the second Best Innovation Award 2016 for AR book, both sponsored by Ministry of Information Technology, Government of India. She has handled several research projects for Internet of Things Group, IHCL, and others. She also has several papers published in various journals and conferences. I extend a very warm welcome to all the persons who are going to present the paper, and I now request Sri Ramesh Srinivas Raghavan to take over and conduct the proceedings.
Thank you. Namasarvebhyaha. It's a great honor and privilege for me to be seated beside stalwarts and amidst all of you. Before I invite the speakers to present their presentations, I just want to recall a memory that I have of having had the privilege to work with Professor Lakshmi Tatacharya a long time ago. And at that time, I also had the opportunity to build a few morphological parsers and analyzers at that point in time. So it's with great pleasure that again, I have the opportunity to sit with stalwarts and see how things are going today. I don't want to stand between you and the presentations. I think each person will need about 20 minutes. Is that sufficient? Okay. So let me first invite Dr. Vedavarthi Ramanujam to present his presentation.
सर्वेषां नमस्काराः अभिनन्दनानि च शाक्यो लोक्याक्षपादक्षपणककपिलामर्त्यवन्द्यप्रधानैः अन्यैराम्नाय चर्चा कवचधृतिकनद्गोमुखद्वीपिभिश्च बह्मीयः क्षोभितापि श्रुतिरिह बहुधा जायमानेन गोप्त्रा काले कालेऽभिगुप्ता कलहमतिचरन्त्यक्षता रक्षतान्नः. Today I am going to present on some of the tools that we have built for helping Vedic studies. And what is the help that Vedic studies need? Itself is a question. Vedas don't depend on anyone else and they are Swata Pramana. But the point is, the practitioners have had some lack. There is some lack of interest, there is some lack of facility. So maybe to make them take little interest, suppose we make some recent advancements useful to their study. And possibly, yes, this is something we are trying. See, oral tradition was the way in which Vedas were taught, not written for many millennia, only maybe about 1000 years ago. It has been written down in palm leaves kind of thing. Before that, it was still oral transmission alone. Today, it has become difficult without a reference as a palm leaf or even let us say as a printed book. So the Vedic learning has a challenge today. If you have little time, then what you try to do is do the practice part more, reduce the theory part. So today most people are not in a position to understand what Vedas say. They are able to at least remember, recollect, recite. This has been happening, but actually this was not the way it was earlier. Initially, it was that you had both Adhyayana as well as Abhyasa of the Vedas. Now, we just want to see that we restore the balance if possible through an external help where ICT can help. In fact, Upanishads have a mention of two kinds of Brahma. One is Shabda Brahma, other is Para Brahma. Shabda Brahma is Vedas, and once somebody masters that, Shabda Brahmani Nishnataha Param Brahma Adhigacchati. This is what the Rishis have said. What are Vedas can be a question. It's a Shabda Rashi. This is how we explain. And what does a Shabda Rashi mean? Okay, I can translate English. It's an aggregate of sound patterns. but then it does not mean all that what Vedas stand for. There is a lot that can be written, but I'll just cut it short to say, fine, it is in the form of sounds. It does not make much sense to write it down. We are actually reducing it when you are writing it down. The emotions or the feelings or the sentiments behind the speech is lost when somebody writes it down. So, we need to have some mechanism to retain the original feelings of the rishis who saw them. For that, we have, of course, an excellent mechanism, even to this date, is the swaras that are used in the Vedas. If the swara is not changed, even who do not understand what you are saying, you are not much off from the way it was seen by the original rishi. So long as, see, what a Gayatri mantra recited by us and Vishwamitra may have lot of difference, but one commonality is possible. The swaras are intact, the letters are not wrong. That's all what is possible. And for that reason, to this date is the only study which maintains the tones or the stress or the wherever you need to highlight, let us say, certain feelings. One simple example I normally give is the word you in English. Suppose someone says, you only should save me. Somebody is in difficulty, he is now requesting somebody. That you is pronounced in a particular way which denotes that this person is in need of help. You call out somebody, you come here, then that you has a different kind of stress. The word is not different, meaning is not different. You did this, you try to chide somebody. This you, how do you write? How do you put a marker to this? But it has a different meaning. You thief. Somebody tells, let us say, a child, then it is not mistaken. Actual thief, if I find sometime, then how do you address him? The word remains the same, meaning remains the same, but the feelings do change. And there are 29 ways in which the meanings can change according to Panini. In Panini's grammar, he has given same word, same meanings, but used in different contexts, can even mean exact opposite also. You just want to say, many times, sarcastically somebody uses a word. Oh, you came on time, right? You ask somebody to come by 10 o'clock, he comes at 11 o'clock. Oh, you came on time, right? So, the sentence does not indicate your intention at all. So, the whole point is why? Why so much of fuss about swaras in Vedas? In fact, we had a very great scholar among us, K. Svardacharya in Mysore. Once he used to tell, swara and jvara are related. If a person is not well, anyone can make out, hearing to him, there is something wrong with his health. The swara is like jvara. See, it can also tell you your health. It can tell you your health whether things are fine or not. So, for that reason, there are some extra markers that are used when they are written down to distinguish them between. In fact, we made this ISKI standard when CDAC started. We started with a standard as an equivalent for ASCII, but enhancing it for Vedic pronunciations. Of course, I was the person who actually did this for all the 4 Vedas, looking at about 13 shakhas, looking at what are the different accents and how to maintain them. Today we have, there is an annexure to the standard, IS 13194. So, this includes the different varieties found in all the different Vedas. And there again, within Vedas there are differences. Each Veda is meant for a particular purpose. Rig Veda is meant to invite the gods, the devatas. So, Hota is the Ritvik, is the person who would recite Rig Veda mantras. Agni Mede Purohitam, when it begins, it just says, I am calling out Agni, the foremost of the devatas, to come and be present here, help us, bless us, kind of thing. So, this is done in certain kind of tone. Yajurveda is used to conduct all the activities of the yajna, including instructing the hota, instructing the homa, udgata, etc. Now, a Rigvedi will call the devatas. The Adhvaryu is the person who runs the whole show. Adhvaryu is from Yajurveda. Yajurveda also is called Adhvaryu Veda. So, now, this person is conducting, coordinating all the 4 Vedic activities in a yajna. So, he asks at the right time, he calls the hota to say, come on now about this devata, this kind of features. You should invite. Similarly, he himself says when Homa has to be done, what should be done. Once the Devatas come and they are present, then we have to please them, singing is done. That is Samvedas. So Udgata is the person who does this. Mostly the mantras are Rigveda mantras themselves, except for about 60 odd Samans which are there only in Samveda and not in Rigveda. Otherwise, rest of them, 1875 Samas are totally there, of which 1800 plus are Rik alone, but sung in a specific way. The accents get increased. We have Saptaswaras, and to them again there are Saptaprastaras up to 49. Naradiya Shiksha talks about. How does somebody include them if you write them down? If you write them down, how to distinguish, number one. Can we analyze them? In fact, what we did in CDAC basically, to this date, what I am trying to do is relate the meanings and the intentions behind to some of the markers that we use. We have some accent markers. Okay? So we just find these are the kind of manuscripts in which we find long ago, maybe hundreds of years ago, our ancestors wrote down. There were no accents in some of them. It has to be learned from a guru. Only the text will be written. These are some of the ways people try to see. One does not bypass a guru. Like today's people saying, internet is the guru or that is the university. And that should not be the way. There should be a person in flesh and blood. You go prostrate before him, seek his guidance, seek his grace. In fact, Gita is very clear. Krishna has very clearly said, if you want to get jnana, tadvidhi pranipatena pariprasnena sevaya upadekshanti te jnanam jnaninas tattvadarshinaha. There is no other second way at all. It cannot be known from internet or it cannot be known even hiding. Prachannena. Even Manu has said, somebody is teaching somebody, you sit in the next room, you don't want to go and prostrate before the guru. You feel very adamant. No. Knowledge is knowledge. If he tells him or me, how does it matter? He is my guru, kind of, that doesn't work. Then it can also become counterproductive. So when things were printed, for example, 100 years ago, printing started. Grantha was the first script in which Vedas were published. They had a lot of thoughts given about accurately representing different swara markers. Now that changed with every script. Devanagari has a different kind of them. We have many manuscripts in Nandanagari script that has a different kind of swara markers. So we have now built a font for Nandanagari also. In our trust we now have Nandanagari font because the originals can be seen the way they are, even on the print. And of course we can still search those accents, etc. So today I am going to look at one very, very special area. It's not very easy to look at swaras, number one. And Panini has initially said, Udattascha, Anudattascha, Swaritascha, Swarastrayaha. In Panini's phonetics, Shiksha, he has mentioned, there are three swaras basically, Udatta, Anudatta and Swarita. Now, Udatta itself is of certain types. There is something like Udatta Tara, which also Panini mentions. Then there is Anudatta has got Dirgha Anudatta, Hrasva Anudatta, Vikrama Anudatta, etc. But among them, the Swarita is the one that is most diverse because of the kinds of relation to the meanings that we expect. There are 7 types of Swarita alone in Taittiriya Shakha. There are 8 in Madhyandina Shakha of Shukla Yajurveda. These are the most potent ones among the Vedic Shakhas, which can make or mar somebody's result, even though he uses the same mantra. If there is a even slight difference kind of. So we have Kshaipra, Nitya, Pratihata, Abhinihata, Prashlishta, Padavritta and Tairo Vyanjana as 7. These are the sutras that talk about Taittiriya Pratishakhya. These are Vedic grammar over and above Panini's grammar. These are for every branch of Veda. That's why it is called Pratishakhya. Shakhayam, Shakhayam, Pratishakham, Pratishakhya Bhavam, Pratishakyam. So Pratishakyas are the Vedic grammar for each Shakha separately, and Taittiriya Shakha has this. Tairo Virama is the additional one to this 7 in Madhyandina Shakha of Shukla Yajurveda. So now what do we need if we want to process this in the computer? Then I have just said CVA. This is one thing someone has to realize. Consonant, vowel, accent. These are 3 components of any syllable. Any Vedic syllable will have, there will be a ka. For example, take the word ka. K is the Vyanjana, consonant there. A is the swara there. Udatta, Anudatta, Swarita is the accent there. Now, this is the minimum most atomic unit. In fact, we have a development of a knowledge structure as opposed to data structure in computer science. We are developing a knowledge structure which has the atomic level CVA included. And the distinction is this A is in the spoken form. It is not in the written form. So, we need to see that the basic unit, the atomic component alone, to also provide for, whether you write or not is immaterial. You can definitely speak them. Now, this is the marked difference, unique difference between, in fact, in 1993, once I had a second presentation I made to then Prime Minister Narasimha Rao. The specific question that time in the Parliament was, what is the difference between classical Sanskrit and Vedic Sanskrit? This was the question asked, and that's when I answered. That is the presentation, of course. Then I did not have for the whole Shakha. I had a few examples. Today we have for the entire Veda, we have a program which develops this. But this is the basic difference between classical and Vedic Sanskrit. You have no freedom or liberty to say the way you like. You have to abide by. If you don't want to change the meaning or if you don't want to alter the result of the recitation. So, CVA, there can be combinations. Say there could be CCVA, CCCVA, it is possible. Number of consonants can be there. See, we have Tarksha kind of word. Ra, Ka, Sha, Ya. 4 consonants, then A comes up. In Ksha, Tarksha, if you have, you can have CC, CCV, etc. C's can be any number of them. V defines the number of syllables. One V makes a single syllable. And single accent again. There could be multiple accents for different components of a word. But when they are all combined, Panini has very elaborate rules on deciding between different componental accents to come up with a resultant accent. Those are the ones, in fact, currently I have been teaching Vedas to students only with this aspect. We also have some, I don't know, we wanted to bring in our publication. We could even show, there are about 20 books that we have published so far. All the accent related things alone. Maybe we have about 5,000 pages of explanation only on accents of Taittiriya alone. Just to explain these many examples, these are the meaning changes, these are the texts that talk about them, etc. So, we now have a scheme in which the CVA of any Vedic syllable can be typed in. Of course, we have made some enhancements even to Unicode. Unicode still does not have all of the accents included, but there are private user area where one could add some more things and build a font for that, etc. There are some solutions, but just to see that if someone wants to have a good help, then it should be meaningful help. You should be able to search, you should be able to analyze, not just browse. Okay? So, traditionally there is one issue, Udatta or Prachaya are not marked in the traditional manuscripts or the printed books. If some letter is not marked, it could be Udatta or it could be Prachaya. Now, how do you distinguish between them? If an unmarked letter is preceded by Anudatta, then it is Udatta. If it is preceded by a Swarita, it is Prachaya. This is the rule. Panini has given this rule, but he mentioned it for speech. But today in writing also, maybe for economy, maybe for ease of usage, people have reduced the letter print kind of press. They had maybe their own limitations kind of. So today what we have done, we have included accents on every syllable. Every syllable has an accent and it is not explicit in the print even. So today we have a database where we can see the accents of every syllable. Then what happens, this is generated through a program and then we have 1,09,000 words in Taittiriya Samhita. For all of them, each one has maybe average 3 to 4 letters. For all of them, a program is today able to give us the accent as per sutras. It can tell you which sutra gets you this accent. So, a programmatic solution is arrived at for distinguishing between Udatta and Pratyaya. That is step 1. Of course, I should mention, we are benefited by 3 individuals. Of course, I am really lucky that they learned Vedas from me, but all the 3 are MTechs in their own field. One of them, of course, is heading maybe Windows 10, 11, etc. developed by him in Microsoft, Mr. Angarajan. He is our webmaster. He has learned Vedas, he is still continuing to learn, but he is also a very good programmer. Yes, programmer. He has been getting solutions to us. Yesterday night, 2 o'clock, he gave me some of this program just to see, fine, if you want to have, so the question is an example to be shown, etc. Next person, of course, is from IISc, from Computer Science Department, ME, with L.M. Patnaik those days. And again, these are all toppers in their batches. He has learned for 20 years, he has learned the entire Vedic literature from me, but he has written most of the open source program. In fact, he has written Bhasha IME kind of. Today, many people use. N.S. Venkatesh is the other person. So, I am lucky in that sense. I was lucky because my father taught me a lot of things traditionally. Also lucky because I got people who could receive that from me. Then what happened? These developments could come up. The third person, of course, is from IIIT, Bangalore, also an MTech student. And of course, Rajgopal, he has been doing some of the work on Python, those kind of things, GitHub, various things. People really do such work because they learn Veda first. All of them can recite the entire Veda today. At the same time, they understand when I tell them this is the problem, this place, this is to be special. Fine, they are able to understand, do that kind of. Similarly, we are extending this now to Rigveda and Samveda. I have, in that sense, about 10 students, 4 from Samveda, 4 from Rigveda, and only 2 from Yajurveda so far. It's good because they learn Vedangas, they learn Vyakarana, they learn Shiksha, but they are able to apply those nuances into today's students. Suppose today's student is given a lot of additional input, then probably the interest will be revived. Okay, so we have used, in this case, I am just trying to see only about, for example, the unmarked terms, if they are to be seen, then how do we do? Of course, there are a lot of details I just skip. The whole point is to convey it cannot be taken easily or lightly. Vedas cannot be equated to anything else. It's on its own pedestal. All other things, including Bhagavad Gita, Ramayana, Mahabharata, they come later. Simply because from the time immemorial, these have retained that feature of their meaning, their efficacy, not changing so long as somebody is able to attach the importance to them. So here are, of course, how do you read Vedic syllables through a computer program? How do you count number of letters? These are kind of things that are, and of course, ISKI standard, since, okay, I have been involved right from the beginning, 1988 onwards. So we at least know how all the efforts have been there, so many experts have come and given their inputs, and how does the program look like, etc. These are some of the, how do you process words and then take action. Word actions are different, sentence actions are different. Panini has got 2 different places. In the 6th chapter, Ashtadhyayi, he talks about the word actions, and in the 8th chapter, he talks about sentence actions, and both are necessary. In fact, a word in isolation will have multiple meanings, but rarely the same word will have multiple meanings if it is part of a sentence, simply because the rest of the words will condition the need to choose one among the multiple meanings that are otherwise possible. In isolation, so many things are possible. For example, there is a word like swaha. Swaha has 3 accents in the Vedas. We find in Yajurveda, other Vedas also we find. Swaha is Udatta, Swaha is Anudatta, Swaha is Swarita. All 3 are there, all 3 have different meanings. In fact, Amar Kosha has given all these 3 their meanings. Now, if it is Udatta, it means asset or property or one's own person, relative, etc. Swaha, Dhana is one meaning, Atmiya is another meaning. It is Swattu, when you use, the Swa is the word which says this is the property or the asset of something. Swa is the word which means the property or quality of something, it could be asset of something. Swaha, when it is Anudatta, it's a Kriyapada, it's a noun, verb then. Swaha Udatta is a noun. Swaha Anudatta is a verb which means 2 of us exist. Asmi, Swaha, Smaha is the. But how do you distinguish? If Anudatta is used, it is only Tinganta or the verb. If it is used in Udatta, Nahi Swaswagam Hinasti, there it is Udatta. No one does harm to his own person. That is what the Shruti says. Swaha Swam Nahinasti. Whereas, Avayo Swamiti, Vayam Swaha. Agni and Soma were caught up by Vrutra once. Then Indra called them out. You are my people, come out. Tvam Avam Yuvam Yuvag Mamavai Yuvag Saha is what Indra said. We agree. We are your Anucharas, your Sevakas. But today, forcibly, Vritra has taken us inside. We are inside him now. How do we come out? Then we are not free now. Avam swatantrav na swaha. There the swaha is used as anudatta. That means it is a kriyapada. I am not able to come out on my own. Then of course the Shruti says Indra created two fevers. Jvara, Shita and Rura. Indra Atmana Shita Rurava Janayate. He created two fevers and he did the mantra prayoga on Vritra. So Vritra started shivering. Then through his mouth these people came out. Then Jabhyamanad Agni Shomo Nirakramatam. So to bring them out, he created either it should affect him one of the ways, whether it is hot or the cold condition abnormal, then he has to react. So when it was cold, then he started playing with his teeth. Then between the teeth, these people came out. Then it says that swaha there it is used. We are here held captive by him. Now that verb is still having swaha but anudatta. Swaha is of course avyaya. Amara begins with swaravyayam swarganaka. Very first word in the Amar Kosha is swaha, which is avyaya, which means swargaloka. Now swaha, one should use it with swarita. In fact, there is also a kavya where Bharavi uses this very effectively. Duryodhana and others, they are going in a place. Pandavas are on the other side. Then somebody says, Swastha bhavantu kuravaha. Let the Kurus be very happy. Swastha is meaning healthy, happy kind of. Then Bhima tells, when I am here, how can Kauravas be Swastha? Swastha bhavantu kuravaha. See, you cannot use the normal Swada. That is Swa. Udatta, when you use, they are our people. Use it with Swarita. No issues. I will send them to Swarga. Now, the Kavi uses this just to mention Swaha, if used with Swarita, means Swarga. So, you won't be Swastha, you will be Swastha. That is the kind of difference. So, for every letter, we can identify what would be the anartha if the proper artha is not known. To that extent, of course, we need programs to see that, okay, they are maintained properly. One, there is a marking. Two, there is a reason. Why do we need the marking? What are we going to do with it? So, unless the purpose is known, it is not just an embellishment. Or it is not a problem to be given to a programmer. That is not the way it was designed. So, the whole issue is, okay, there are some further details about programs which I will not go into. There is one thing called Varnakrama Patha. This is one word I think if people remember. Varnakrama is one type of recitation of the Vedic mantras. This is an explanation of all the details of every syllable of Vedic word. Now every syllable I said is a CVA. Now every C has got, every consonant has 8 properties, 8 parameters on it. Like Dhvanihi, Sthanam, Karanam, Prayatnam, Devata, Jatihi, Angam, Varna Samjna. These are the 8 parameters for every consonant. So where does this sound emanate from? Where is it getting reflected from? What is the type of it? So there are such details about effort required, internal effort, external effort, etc. So this is a specific detailed explanation of a single consonant. Now a vowel also has got 8 such gunas. A little difference between consonant and vowel. Vowels have duration, Hrasva, Dirgha, Pluta, and vowels have Udatta, Anudatta, Surata, accent. Consonants have certain features, vowels have certain other features, but both have 8 parameters for each of them. Then comes the...
Excuse me, sir. Can you please wrap up in another few minutes?
Sorry?
Time is up.
Oh, I
please
see.
wrap.
Okay. Then what I will do is, I'll just try to give only one example and leave it. See, Prajapati is the word. Now, there is a word like Prajapati. So, this has all the 4 accents. Anudatta, Udatta, Swarita and Pratyaya in the single word. So, Prajapati, this is split into Pakara, Repa, Akara. Pra has got Pa as a consonant, Ra as a consonant, then A is the vowel there. Then similarly, Ja has got Ja as the Jakara as the consonant, Akara as the vowel there. Then Pa again, just Pakara, Akara. Then Ti, Takara, Ikara, then Visarga. These are 10 components. Atra dasha varnas santi. Each one is called a varna. Why we call this as varna krama is every Vedic letter has varnas, that is C, V and A are individually counted to just see their properties are mentioned. Now for a letter like Ka, every accent has 10 parameters. 8 plus 8 plus 10 becomes 26. And that is what is just shown. This is, I think, this is the one I actually presented to Narasimha. For one word like Madhavaha, it took about 15 minutes to recite the explanation. He just said, I am amazed at the level of achievement of our ancestors. This was the reaction from the Prime Minister then. For one 3-letter word, Madhavaha, the printout was about 1.5 pages of A4 size paper. Then I recited it. This much of detail. And so much is packed into that is shown, and this is just recited by committing to memory. Something amazing. That's the kind of... so, the purpose is to just see that Vedic and non-Vedic have a significant difference. It is not just that it is cosmetic. It is not. In fact, there is one more thing to also support this. The Vedas themselves say creation happens from Vedic sounds. Creation starts with Vedic sounds. Now, a sound that can create an object is something different from any other sound. So, from that reason, so we have this kind of Udatta Swara Yukta. See, if I just read out one, Samvrta Kanthotthita Samvarakya Bhakya Prayatna Vishishta Nada Dhvani Janita Ativyasta Kalpa Hanusthana Tatha Bhuta Ushtakarana Vivurta Prayatna Dvimatrika Bhumi Devataka Brahmana Jati Sattva Guna Sahita Tarjanyanguli Madhya Rekha Nyasa Yogya Sharirayama Lakshnikita Gala Bila Vinisrita Parushadhvanika Aja Vikaruta Tulya Gandhara Swara Hetu Bhuta Murdha Sthano Utpanno Datta Swara Gunaka. This is only 10 parameters of the Udatta alone. This way you just run through, this is the way it is committed to memory by people, just remember. So, in fact, people used to do certain Shirashasana kind of yogic practices to get that kind of memory. So, this has been mentioned in Sadhvada Brahmana. So, this is the kind of greatness I have just tried to put as a table, the abstract of all this in English, okay, for someone to just even appreciate what is being talked about. What are these individual letters, and then in different columns, if we put those different values. So, these are now generatable through a program. So, that is what we have just done. So, now we have Panini has given this Sana is this, Devata is this, Jati is this, different Saritas, what they have. So, ultimately it is something like within your mouth, in your system, from within the body, when the bodily fire sends up the air column up, and it comes through the windpipe, and then it gets generating different sounds through different paths that it follows. Then the process of sound production, it is not analyzed so nicely in any other language, simply because we do not have such a kind of purpose. Okay? This is done only for example, where is it open, closed kind of thing, somebody can show this is the path, this is the path. Today it is possible to use certain kinds of, and because there is something called Hasta Chalana. Different accents are to be shown by the index finger, touching different other fingers in different places. And this again, these are Panini Shiksha Slokas, he has mentioned. We could today show them maybe in a number of ways. I have what are called as Veda maps. Today I have just tried to make Shastra maps, Veda maps, etc. Just trying to show the contents of the Shastras in the form of something which is better visualized. But it requires in-depth knowledge to design a proper system. Then it could be appreciated. So, this is the word Madhava I was mentioning, Makara, Akara, Udatta, Dhakara, Akara, etc. And this is the explanation in a short form. This is what was presented to the then Prime Minister. So, thanks, and I think if there are any questions, I don't know if it's up to the chair, the way he would decide. Thanks a lot for the opportunity.
Thank you. We have time for one question, and if there is time towards the end, we can have one more. One question.
Thanks, Dr. Abhasjam, for the wonderful presentation. We have been discussing this. Can you map the CVA concept to the Sanskrit descriptor technicality? Are you looking at CVA as Varna, or is it Akshara, or what exactly is the Sanskrit technical term which will describe CVA?
Yeah, we have the word akshara used, the Veda aksharani yavanti patitani dvijatibhi. When we say the Veda aksharani yavanti patitani, kaityesha udahrataha, shadvinsadirita dharmaha, kaityesha udahrataha is what Vyasa Shiksha says. Ka, if you take a letter, it has got shadvimsat dharmaha. This is what we said. Acha has got 8, Al has got 8, the Udatta they have 10 kind. Now this ka is treated as an akshara. Akshara, that is the syllable, maybe, I don't know. English equivalent is difficult always, and I am really not interested in finding English equivalent. Why should I use English at all? I have no need for it. So the whole point is, I am comfortable with Sanskrit and I am lucky in that sense. That is the end of it. So even many times people have fought with me in CDAC, no, we should work on all Indian languages. Yes, I am doing for all Indian languages. No, English also is an Indian language, somebody wants to argue. Then I work on non-English Indian languages. Let me be very clear. So my interest is only so much. So the idea is imprecision comes from outside. Apramanyam parataha. Now you try to force it onto something and then say, come on, find me an equivalent. We don't need a Money Williams, we don't need somebody to mistake or misuse things. Just don't use that language, there it ends. Or be deprived of this, wait for a janma when you will be suitable for this. This is another way. See, there are a number of solutions. Okay, you become eligible, fine, then it will be. See, we can also become Maharshis. I have many times told, I many times feel I should have been a Maharshi, then maybe I would have seen the mantra myself. Then don't have to believe on others kind of. It doesn't work, so you have to go through a guru. Now, what the guru does is ultimately, he is just trying to train you by his repeated saying something. Then there we have this, the Sattva Brahmana says, gurus out of compassion use Padapatha, use also the Dhruta, Madhyama, Vilambita Gatis to make things clear to the person. You can make it very slowly, you keep on. That is, in slow motion one can try to train the student, but ultimately it has to come from him. If Vishwamitra teaches Rama Dhanurvidya, he does not forget it, and he makes the student equal him in his ability. See, it is not the transferring knowledge, it is transforming the student to reach that level of the Guru. That's what the Vedas meant. So, Akshara is generally the word that is used. Akshara, because Vedaksharani is the way we find in the Shiksha. But I think this was not thought to be so important. How do we label something? Or, see, Varnas, for example, Varnakrama, Shruti also has Varna, Swaraha, Matra, Avalam, Samasantana. There is Varna. See, Varna can include just a Hach alone, Hal alone in different places. See, the example Shruti has given is two students actually tried their Vedic knowledge for efficacy. One person called Ramedha, other called Paruchepa. These four, both of them went in front of a live tree, a tree that is wet. And then they started saying, there is a mantra to create Agni. When you churn out of the wood, get the Agni, there is a mantra. Then these two said, okay, let us go and recite this mantra in front of a live tree. It should catch fire. So when Rameza said this, only smoke came out. Paruchepa said this, then it actually caught fire. Then Rameza told Paruchepa, you have become a rishi. Then what is the difference between you and me? We have been all the time studying together. Then he says, I know the varna which you are lacking. Samidhenina mevaham varnam vedetya bravit yet samavad vidva kathatvam agnimajijanaha nahamiti is the question. We have both studied together similarly. You created Agni, I did not. What do I lack? When he asked, aham varnam veda. He said, Samidhenina mevaham varnam veda. So the idea is, it could mean conviction, it could mean faith, it could mean any kind of thing. It's not visible, it's not concrete, but it makes a difference. And so Varna also is used in the Shruti, but Akshara is generally the word in the current parlance, the way we discuss in the phonetics kind of thing. But I really don't know whether it really makes so much of difference, whether you call it as Varna or Akshara, so long as you are not entangled into writing. See, if it is speech, there is no trouble. We now try to get into written form, and then we want to make this map to that kind of thing. See, this is something like an unnecessary, unwanted thing created by us, and then getting into a problem for that. Who asked people to write them at all? It was never expected to be written down. See, in English, they put the question mark in the end of the sentence. What is your name? You put a question mark in the end of that. Tone of interrogation should be there in the whole sentence. Suppose only that mark is last. What is your name? Then it will become an affirmative sentence. Is that the way it should be written? Kind of. So in writing, it is not possible to have this pervading through the speech itself. What is meant for speech? I remember 1993, there was also a similar workshop done by Professor Lakshmi Dasacharya on Shiksha Shastra and experimental phonetics with NIAS, but it was done in the Choksi Hall. At that time, we had our Rangnath Sharma who had come. He had mentioned, I was talking about the accent, he said, in Kannada, I will give an example. He said, Ivaru namma atte. One sentence he said. Nanu Golonta atte. He said. Both have atte, but they are not having the same meaning. ಅವರು ತಮ್ಮ ಅನುಭವವನ್ನು ಹೇಳಿದರು. ಇವನು ನನ್ನ ತಮ್ಮ. When you say this tamma, it does not have the same accent. But he also made a joke when he said about the swaha. Neevu yavaga bandiri. Is this the way he asked people? He was asking. I said, okay, it is not necessary. See, Kannada cannot imbibe the entire thing that is there here. But the point is, yes, you are a grammarian and you know Prakriti Pratyaya Swaras. Yeah, I was just joking. He was saying. So it's difficult to actually see. When you write down something, it don't become the exact equivalent of it. And terminologies, even standards, I would say. Standards was not the way like we see it today. It was by producing effect and seeing. In fact, people have said when uttering wrongly certain words, certain accent, undesirable consequences have happened. This has been mentioned in the Shrutis also. Vinayakam Prakurvanaha Ratayamasa Vanaram. This can happen. So, those are kind of things. Anyway, so I am not very sure about mapping or the terminologies part. But I am comfortable not getting into written mode of Vedas, number one. Number two, definitely avoiding English so that much of headache is off for us. Indian languages, they can share the same word, so we are safe that way. Yeah, I know your interest and your Kannada and software and all I have seen. Yeah. I agree. See, Nada, you made it. Kannada is of course known. Kannadam Panini has been there. Good. Happy for your efforts, but maybe some places will be still requiring time to find proper solutions or acceptability. I don't know. Okay.
Thank you, sir. Big round of applause. Thank you. I now call upon Dr. Nitin Nagaraj to present his presentation.
Okay, so we'll now return to, from the lofty heights of Vedas, I think we'll return to the more mundane level now. Thank you for this excellent talk, sir. So to begin with, I think I should thank Dr. Alvar for the opportunity to present our work. But I should also warn that this is just a work in progress, and I'm by no means an expert in this area of IKS. I'm learning constantly from my colleague, Professor Shailaja Sharma. And our inspiration is actually Professor Rodham Narasimha, the late Professor Rodham Narasimha. As you probably know that he was an eminent scientist. He was a giant actually in the fields of fluid dynamics, aerospace engineering. But he also did, I would say, phenomenal work in establishing or formulating some of the epistemology behind the Indic way of doing science and math. So we draw our inspiration from him. In fact, there's a photograph of him giving a talk in this very hall on this very subject actually. So yeah, so this is actually the kind of the paper that sort of inspired this particular presentation, where Professor Narasimha talks about two sciences, you can say two cultures or two traditions. And so basically, I mean, there are at least two ways of doing science. There are actually more, but let's stick to the two of them here, the Greek way and the Indian way. And pretty much here, everybody in the audience here, including myself, is probably trained in the Greek tradition, fortunately or unfortunately. And it's only much later that we come to appreciate the Indian way of doing things, right? And Professor Narasimha brings about this contrast in a very nice fashion. So he talks about this buzzwords, right? This is what you learn in your school and college and degree and all that. Axioms and proofs, and I mean, without a proof, nothing works in the Western, in the Greek tradition. Theorems, then laws, deductive logic, rationality, and then there's a whole emphasis on beauty and perfection and symmetry. That's what you see in physics and math and geometry and all that, right? And it's all about universalism. You want like one theory which fits everything, which explains everything, and it's a sort of a grand thing, Now contrast this with the Indic buzzwords. So I've taken this, shamelessly from Professor Narasimha's presentation. I've given the reference there. I mean, beautifully summarized actually, right? All the words you see on the left-hand side used by the Indian astronomers and logicians and practitioners of the Indic way of doing things. And the right-hand side is the translation by Professor Narasimha himself, So you have Prayojana, you have Yukti, you have Anumana, Ganita, Drigganita, Drigganita Aikya, Siddhanta. So he was very clear in saying that Siddhartha is not theory. Siddhartha is processed conclusion. That's what he liked calling that. Samskara. So these are the Indian buzzwords, the Indic buzzwords. And there's more. There's more. You can see all the way till Sampradaya. Then you have, Samskara and things like that. So the argument that he's trying to make is that the entire Indic way of doing this is very, very different in nature and character from the Greek way of doing things. And this is what he called the computational positivism. I'll come to this in a minute. So positivism itself can be defined in the following manner. It is any system or epistemology that relies on data of experience, and it sort of emphasizes the rejection of any metaphysical speculation. That's why it's called, you need positive experience or positive data to actually get knowledge. And the famous example is, of course, logical positivism, which thrived in the 19th to mid 20th century. And clearly there's a hierarchy of levels here, that numbers are the real thing, and geometry and mechanics in that sense is lower down the chain. But the most important thing to remember is that metaphysics is given either no importance or less importance. I mean, that's usually the case. And computational positivism, what Professor Rodhan Narasimha defined in this 2003 paper is the following, that it's the epistemological system that is implicit in the classic Indic approach to astronomy. And of course, it's all about observation and experience. So you can say pratyaksha or pariksha, whichever way you want to see it. And of course, there is reasoning. Anumana is also there. But the main thing is that computational procedures or algorithms that are in agreement with this pariksha, that is the most important thing. And it rejects a priori models or theories, seeing them as best a posteriori constructs to be derived from successful algorithm systems. So it's not that we completely dismiss theory, but it's given a second or lower importance. And the characteristics of some of the characteristics of computational positivism are the following. You want a sort of a concise description of nature through algorithms. That's the main thing. And if there's any discrepancy, we have to tune our algorithms. We have to come up with better methods to explain the observations. And of course, observation and facts and computation, right? And anything logical which is inherent in the use of numbers. And here we're not talking about obviously the Aristotelian logic. And the Indian logic, as we know, is multi-valued, and I mean, there's a lot of nuances in the Indian logic itself. We'll not go to that. And this whole debate between Yukti and Agama, I know that it's a long-standing debate, and but you notice that how the nature of the Indic system is so different from theory and axioms and models and appeal to those, and observations are sort of seen as sort of secondary or models are more important in some sense. Now. So Professor Narasimha would sort of quote this as a good example, in the modern, if you look at a modern example of a scientist par excellence, Richard Feynman, he quoted Richard Feynman, and Richard Feynman himself actually made these following interesting statements. He said that, look, I'm more of a Babylonian, which is actually the even before Greek, and it's much similar to the Indic system, but of course not as advanced as the Indic system. And he says that I have no preconception of how nature is like or ought to be. That's what Feynman says. And this is the debate between him and Dirac. Dirac was this, the more Greek, you can say the Greek representation there. And he says that, look, I don't tell nature what to do. Nature tells me. And logical stuff, a monster. And we saw this, right, with all the work of Gödel and, Russell and, all the logicians, right? How logic can be so tricky. And what he's saying is very, very important statement, that a very great deal more truth can become known that can be proven. So there's a thing about computational truths versus mathematical truths or so-called mathematical truths, right? And there's a very famous dialogue between Pauli and von Neumann. And Pauli is struggling with a problem, and he solves it eventually. And von Neumann says, look, you could have solved it by just having an axiom, one particular axiom, and you would have done it in no time. And then Pauli says to him, Herr von Neumann, if physics could be done with axioms, you would be a great physicist. So notice this whole thing about that many of these physicists embodied this indic way of doing things in that sense. This observations and data is more important, and the axioms have to be very, very careful about axioms. They can be very, very tricky. Now the question is there a revival of computational positivism? That's the question we want to ask. I mean, it's not a question that we have asked actually, and this is something that Professor Narasimha and other people have also asked. And in that 2003 paper, you can notice Professor Narasimha making these points about probably there is a revival, and there are several examples that he gives. One is the cellular automata, this entire approach by Stephen Wolfram. Mathematica, I think people here would have used Mathematica, the software, right? Where mathematics is computation, or the universe is a simple program. That's the kind of the worldview that Wolfram brings about. And of course, the whole study of dynamical systems using computers. We saw that you can't solve it analytically, so you have to use computation to understand dynamic, like for example, weather modeling, right? So that's entirely more computational in nature. Big data, so Professor Narasimha talks about big data, how the whole epistemology is towards observations and data, and how that exploration of data, for example, and then, of course, this whole thing is what is behind this agents of change. So behind this agent of change is, of course, the Indian numeral system, algebra, a new language of equations, computational power, and all that. But what is very interesting is that Professor Narasimha quotes this. I've taken this quote from his talk. He says that a variant of computational positivism is going to return to the world of science. He said this even a couple of years ago. I mean, he said this long time back as well, and other people also said this. So the focus of my talk is, are there examples of this? Are there concrete example today that this is the case? So let me give you 3 examples. I'll give you 3 examples. One is artificial intelligence, and I think yesterday there were some talks on this. Now, if you look at, if you go back to the 1950 paper of Alan Turing, he asked this question: can machines think? And this particular paper is you can say one of the most important papers of AI. And in a lecture in 47, Turing made this very interesting statement. He says that what we want is to build a machine that can learn from experience. Okay, and this is the earliest mention of intelligence actually in this particular talk. And what is important to remember is that today all of AI, at the heart of AI, is this actually thing. This emphasis on experience, emphasis on data, emphasis on observations. That is the main thing, not models, axioms, theory, not that, And it's at the heart of everything, even ChatGPT and everything that we use on these apps, on these phones. It's all about observations, experience, right? And how to learn those experiences. And if you look at AI itself, very interestingly, it has also followed this thing about plurality of methods. In fact, it's called anarchy of methods. That's a famous quote. You can find this in this 2014 paper. That earlier there was this logic and expert systems which talked about logic, symbolic AI, and deductive reasoning, but that soon was found not to be very, very successful. And what is really today dominant in AI is computational statistics and biology-driven methods, wherein again it's about algorithms and data-centric methods, not model-centric methods. So we really, in some sense, don't so much care about the model. The prayojana is important. The prayojana, the objective function, the prayojana, that is the forefront of AI, and we want to optimize the prayojana. And theory is sort of backstage, And this actually created this whole thing about, in the West especially, you can see articles like, is it the end of theory? Anderson's, this famous Wired article, this is the end of theory. And then there's even as recent as last year, that are we witnessing death of science in some sense, post-theory science? And look at the statement, humans turn out to be deeply uncomfortable with theory-free science. That's what it says. And of course, the question you can ask is, what science, whose science are we talking about, right? So remember the 2 traditions, right? So maybe it is the death of one kind of science. I mean, people are not even aware of the other kind of science, right? Which we are interested in. And this is where I think there is this return and revival of a type of computational positivism. I mean, may not be exactly the same fashion as the Indic system, but very, very close to that in spirit. Okay, and of course, so much so that people today are talking about deriving the laws of physics using machine learning. Deriving the laws of physics using machine learning. Whole bunch of papers on how you could just look at observations. So you can drop objects of various masses, capture it on a video camera, churn the data in machine learning, and try to derive the equations of Newton's laws, and it's been done actually, it's been done. So you can do this, just observations can do the trick for you. So much so that people are even going to the extreme to suggest that the universe itself is a computer. The universe itself, before the laws, whether it's law of thermodynamics or any of those famous laws, possibly there is this meta law of learning through computation, which the universe is doing, and it's called the autodidactic universe. I mean, all these are, I think, controversial and contested today. But this is what people are going to extreme, saying that theory is, loss and theory is one way of doing things, but let's go with AI, machine learning, data-driven science. That's what it's called, right? Data-driven science. Okay, this is the first example I wanted to give. Of course, mathematics. You might wonder what's happening in mathematics. Now, even mathematics, there is this thing about, for the first time, ML has been able to find connections and patterns which humans have missed. So there is this article in 2021 in Nature, actually, paper in Nature, which talks about how DeepMind can untangle the mathematics of knots. Very interesting thing. So even in mathematics, it's becoming more empirical. So this whole thing about experimental mathematics and empirical mathematics, using AI and machine learning to do that. The second example I want to give is regarding ICT, because I think the whole thing is on ICT, this whole seminar. So let me sort of very briefly tell you about information, right? So we know about Shannon's work in 1948. He wrote this, Claude Shannon in Bell Labs, and later in MIT, he wrote this paper, masterpiece actually, which is about mathematics of communication. And the impact of Shannon is everywhere, right? All disciplines, whether it's communications, coding, encryption, even in causality, study of consciousness today in scientific theories of consciousness, neuroscience, everything. This phone works because of Shannon's work, actually. They all use information theory. And Shannon's thing was entirely axiomatic. He came up with axioms for information. And but what is interesting is you can perturb those axioms and you'll get other entropies. You perturb those axioms, you get other entropies. So the question we can ask is, okay, it's great, this framework is amazing. It's very powerful, it's axiomatic, but there are lots of issues with it, which is, so just to summarize what's happening here is that things are true when you have lots of data, things are true in asymptotic, when you go like asymptotic, and things have assumptions about ergodicity and Gaussianity and things of that nature. And the problem is, the moment you have transient phenomena, when you have finite data, when you have missing data, when you have noisy data, much of these Shannon's, it works to some extent, but there are problems. And the blame is put on the data. Look, you don't have good data, This is a problem. So this is the thing, right? In theory, there's no difference between theory and practice, but in practice there is. This is a problem with much of this kind of a formalism. So I'll give you one concrete example why this is a problem. Conditioning. So if you look at H is the entropy of x given y is always less than or equal to entropy of x. For example, let's say that x is observing smoke and y is the event of a fire. So if you know that fire has occurred, if you know y has occurred, then the entropy of the surprise of x is having a smoke is less, right? So you get less surprised if you know that there is fire. You get less surprised in the event of a smoke if you know that fire has already occurred. This is what it means by conditioning. And conditioning can never increase entropy. It can never increase the surprise. Okay? And this is actually problematic if you think about it, right? What if you have fake news? What if you have some information which confuses you? Now, Shannon will say that that's not possible in the theory. In the Shannon's theory, you will discard that, conveniently you will discard that and you will never get confused. So this is where you have to look beyond information theory, wherein you'll have to come up with a way to practically model these situations where the extra information is actually problematic. It confuses us. Shannon's theory will not be able to answer it in a straightforward manner. So let me give you a very practical example which everybody can understand. Let's say that you see this picture and somebody sends you on an email and you get the head of this lion, right? And you're surprised why this friend is sending you this. And after some time, you receive the remaining part of the body of the lion. Your surprise is not much. Okay, you expected that, right? You expected that. What if you received this? It's possible, right? You received this from your friend. This is actually a liger. By the way, it's a species which is a stable species. It has characteristics of both lions and tigers. It's a very interesting thing. Now, what is amazing is if you try to model this thing, this perplexing phenomenon, using information theory, what Shannon will say is this. The surprise of seeing a lion head given a lion body is less than the surprise of seeing lion head given tiger body. I think this is fine. There's nothing wrong with that. The right hand side is more surprising, right? Second statement also is fine. The surprise of seeing a lion head given a lion body is less than seeing a lion head. That's I think also fine. Where it fails is here. The surprise of seeing a lion head given a tiger body is less than surprise of seeing a lion head. This does not make sense. This is what Shannon will say. That look, the tiger body is confusing to me. I'm going to discard that. You can't model it, You can't, because remember, conditioning reduces surprise. Conditioning reduces any kind of uncertainty that you have. It can't increase it. So looking at the tiger body, given the lion body, tiger body, if you receive the lion head or vice versa, that conditioning can only reduce the surprise. It can't increase the surprise, So this is where we have a problem. And we need to go with, we actually desire this. We want to have a way to increase the confusion, So, and how do you do that? Actually, it can be done. This can be done. And how do we do that? We use this notion of complexity, wherein we want this thing that given the tiger body, when you see a lion head, I want to be perplexed. I want to be confused. Hence, it should be greater. That complexity should be greater than seeing the lion head. And this can be done. And how to do this? So, in other words, what we're claiming is all three equations should be possible. For Shannon, that's not the case, And this is where actually we use data compression algorithms. We can use data compression algorithms. There's a whole nice history of data compression. I think in the interest of time, I'll just mention this. Lempel-Ziv. Everyone here uses WinZip or gzip or whatever. That's based on Lempel's algorithm, which is an algorithm which is actually a probability-free method. It's a probability-free method. It just uses dictionaries. It uses computation. It uses algorithms to actually compress the data. And hence, the compression algorithm, the algorithmic route is a better approach than the information theoretic route. The axiomatic, the baggage of Shannon, it can be avoided. It goes all the way back till 77. And there's a huge history behind this alternate formulation, the work of Kolmogorov and arithmetic coding and this whole thing about algorithmic information theory, where built on the work of the Turing meets Shannon, computation and information, dictionary building methods. There's a whole development of algorithmic ways to do information theory, information science, you can say.
Sir, can we wrap up? Can we please wrap up in a minute?
Yeah. So, just give me a few. Yeah. So, and we have used our own methods called compression complexity. I'm going to skip this. So, it's an algorithm that we use, and it is completely based on computation. So, all three cases are possible. That is, given the tiger body and the lion head, right? Given the lion head or the tiger body, you receive the other one, you'll be more perplexed. That's actually possible. So, and remember that case 3 is impossible for Shannon. Okay. And this particular algorithm that we designed in 2013 has no assumptions. We don't make any assumptions. We don't use probability. Okay. It's algorithmic. It's very much in spirit of the Indic tradition. And it's been used everywhere. It's been used in a lot of places, a whole bunch of list of algorithms here. And this is what I wanted to say, that the problem with probability-based methods is that which theory of probability to use, right? There are different theories of probability actually. So computational approaches sidestep this entirely, and they look at patterns in the data. And they're data-centric and not model-centric. So this is one example of the revival of computational positivism in some sense, a type of that, you can say. And the last example I wanted to give very, very quickly, I know that I don't have much time here. This whole theories of consciousness, there's a whole bunch of theories of consciousness out there. And many of them, I've just marked one of them, the integrated information theory of consciousness, which is a very popular one today. And it turns out that there has been some work in trying to connect that with Kashmir Shaivism, the philosophical aspects, not the scientific aspects, the philosophical aspects. And the argument made is that in the Abhinay Gupta's model of Kashmir Shaivism, the subjectivity is related to causality, which is not the case in Shankara's Advaita, and there's a whole bunch of work going on in this direction. So the point I wanted to make is that this whole, okay, just to sort of summarize, this is my last slide, that if you look at the brain science, right, the neuroscientific theories of consciousness, it's still at a very Faraday stage, as the famous scientist Ramachandran mentioned. And I think the IKS interface systems can very much help in that, and I think we listened to this even in yesterday's talk. And the puzzle of consciousness is also central to AI, and we know that for well-being as well, some of these Indic systems are very, very important. So this is what I just want to say, that I think there is a revival of sorts, a type of computational positivism, may not be exactly the same way as the Indic method, but very, very close in spirit, I would say, in terms of AI and in terms of information science. And I think there are some exciting times ahead, I feel, and we sort of have to own this up, and we have to emphasize that the Indic system is sort of back in a different avatar. Thank you all.
Thank you, sir. In the interest of time, we'll take only one question.
Sure, good.
Just want to check with you. Is there a possibility of having a data-based approach to predict black swan events.
When you say data-based, but the only problem is you can't cover all possible cases, right? How big your database is going to be, right? I mean, for example, this is the problem, for example, even in self-driving cars, you have a long tail, you have lots of events which are low probability, and no matter how big the database is, something new which may happen which may not be in the database, right? So I'm not sure whether you could do that. I mean, it's a very tricky proposition, right? Because you can't think of all possible scenarios ahead of time, right? So, I mean, that's just my initial response, We can probably discuss more, sir. Yeah. Thank you.
Thank you so much. Sir, I know there are many more questions, but we are very close to the lunchtime. So if you don't mind, you can please carry the discussion outside. We have one more speaker to go. Sorry? Let me invite the next speaker, Dr. Sarita.
Yeah, full screen adjustment. Yes, please. Yeah. Sri Gurubhyo Namaha. I just want to introduce some ICT tools for Sanskrit, Vedic and Manuscript knowledge preservation and propagation. This has been the research works which we have carried out for the past 25-30 years under the great guidance and it is very privileged for us to work with Dr. Ramanujan in CDAC to collate all these research works and bring it into one single website where people can able to search and can able to go insights about that. So my outline of this presentation is like introduction, and would like to introduce how the non-Unicode era people has to handle this and how Unicode era has bring it into changes, drastic change happen, and what are the challenges we have faced and what are the ICT tools has been developed and what are the e-learning tools that has come into the picture and what are the current trends going on and what is the future scope. So this is what my talk is. So Indian heritage and language computing, it is the main purpose is for designing and developing language technology systems for preserving, processing and as well as propagating ancient Indian knowledge database and also the heritage and culture. This is what the prime area of Indian heritage and language computing, and we have sophisticated technologies are there where we are able to start from the keying in the text and the speech, AI and NLP tools has been brought up, and along with that knowledge structure modeling and training is also part of the research works. And we have expertise in NLP, multilingual application development, Sanskrit and Vedic application development and manuscript processing and training programs in the field of NLP, and currently working in natural language translation machine where we are part of the consortium projects where the translation is happening from Indian language to Indian language, that is from Hindi to Kannada and Kannada to Hindi as part of that. And along with that, there is one more prestigious project under in consortium with IITs and KSU, IISc. So that is Sanskrit Lingua Interlingua Consortium project where it is a prominent role. So in translation from one Indian language to another Indian language, what is the prominence of Sanskrit? That means can it behave as an intermediate superset where the translation helps it for machine to translate from one language to another language. So we have taken the steps towards all neural methodologies, that means NMT, neural machine translation has been taken up. So that the work is going on, the research work, just I want to bring to your notice. So the pre-Unicode era. So anyone, a layman, a baby wants to sit and type with the Sanskrit. So how it has been happened from 20 years before onwards. So CDAC has come in front actually, up front, and start working with the standard called Indian Standard Code for Information Interchange, where the same keyboard which has been designed for ASCII has been used even to type for Indian languages. So with that introduction, the standard is for ISCI 91, and the files which has been typed in Indian languages, including Sanskrit, so will be saved it as .aci files. And how this mapping? Yesterday, Prabhu sir, Dr. Prabhu was admitting the same thing, why Unicode is having totally different Unicode sets, each and every glyph. But our Indian, already in CDAC, okay, they have started with giving the same code for typing the different languages. So with the ISCI. So if you see here, till 128, from 0 to 128 ASCII values mapped for English, and from 128 onwards, the remaining till 256 has been mapped for other Indian languages. So if you go with some O is there, 192 is there, O is there. So 192 is being same code is used for typing any type of language. So how to use to do? That is, I will just introduce that one also. And another one is like a phonetic code, because Dr. Ramanujan sir well versed that without accents there is no value for that. So phonetic code, how to be printed, because whichever is printed. Now, sir, I'm not telling about Datta and all. So whichever is able to print on that one, how to do it. So for that, PC ISCI has been formulated with the extension with the ISCI. And the keyboards which has been formulated was Inscript, phonetic, and as well as typewriter. So the same keyboard has been mapped with the ISCI standard to other languages to type, along with Vedic keyboard layout has been formulated in CDAC, where we can able to type Yajurveda, Samaveda, Atharvana Veda, all Vedas accents can able to type. And this is the keyboards which has been designed or formulated, I can say. And unfortunately, I think now it is not been standard even for Samavedic keyboard. This is the only glyph you had to use for typing, even though Unicode has been has come into the picture. So how it has been happening is, suppose the ISCI is being there, the code format is there. If you select any type of the language, which language you want to type, so by using monolingual fonts, bilingual fonts, and along with rendering DLLs, so a code has to be formulated called, we are calling it as ISFOC, which is a font code it is. So font code will be displayed. So the font code is able to overlay onto your screen. So it cannot be possible immediately as is like in Windows machine. So it started with actually gist card. It is only for DOS systems it has been started with the gist card. Later for Windows systems, ActiveX controls has been formulated, as you have seen in this picture, and where different types of languages can be keyed into the system actually, because we can able to render it. So for this we need so true monolingual and as well as bilingual fonts has to be formulated. So DVT Surek we used to call for, we used to use for Vedic accents to type, and for normal Sanskrit and other languages we used to type for TT Surek. So such type of fonts has been used. So coming to the ICT tools which has been developed based on this technology. So first, as everyone has to start learning from Sanskrit, so the team also has started by learning with the Swadhyaya. So it is a self-learning software for Sanskrit, and it has been covered only Prathama Diksha of Sanskrit courses, which is sponsored from Rashtriya Sanskrit Samsthan, and it is having multimedia support also. So under that 4 Diksha books we have converted, we have digitized, and we have made it as a CD, and which has been released in the World Book Fair in February 2010. So the books were like Varnamala, Kavya Vyavahara, Kavya Vistara, and Sambhashanam. So, and the next, after Swadhyaya has been completed, next one is, I think everyone knows this picture very nicely, Vedic literature, where Shruti and Smriti is there, and the total research works are going on under Vedas, Brahmanas, Aranyakas, Upanishads, Vedangas, and Itihasas and Puranas. But we have not attempted for Upaveda and Tantras as such. Other categories we have collected. So Dr. Ramanujan was the behind the iconic person who had this interest and made us also ignite to work towards to achieve this success. So another morphological analysis has been done with Desika, that is natural language understanding system for Sanskrit, especially for noun analysis as well as noun generation, verb analysis and verb generation, and morphosyntactic analyzer has been developed. And there is very good editor called C Vyasa. This is an Vedic, we can make it as both Sanskrit Vedic editor, where you can able to edit, format your text, as well as you can able to print and publish it also. This is very much helpful for the research scholars, where the person wants to give some citations or references to other books. They can search in the same text editor itself, so without going away from the tool. So this is one of the invention, I can say, so where it will helpful for so many scholars. So you could have seen here so many books like Alankara, Amarakosha, like that, so many are there. So all these books, the ancient text, we can say, that has been digitized as separate application without Unicode. Means before Unicode era, I'm telling. Now also we have available, all our MFC applications are available in the form of CD, where you can able to browse, search, and you can number search, you can able to recite it, you can find out the other insights in that data. So that has been still available, but it may not work with the current machines. We need to total translation is required. So Rigveda, like this applications has been designed, all the nearly 35 applications has been developed. So Deccan College Sanskrit Dictionary also has been created as part of this. Sri Mahabharatam, if you see here, Samasa tagging is one of the special feature, where for all the parvas it has been tagged in the Mahabharata. Still it is available, the Samasa. I think, sir, no one has done this work after you, I feel. Yeah. Okay, but there's still, yeah. So technology issues was DOS based, Windows based and all. So there is no DTP tools and fonts as such. They're incompatible with operating systems and the different browse. There is not support for the browsers also, and applications whichever developed was not compatible with across all the devices. But you know that mobile is right now, the technology is taking away, and we are totally addicted with mobiles. So we had to think how to can able to even bring to the mobile based systems also. So Unicode has been coming to the picture, where it has been standardized the glyphs, browsing problems and rendering problems, and operating level, even browser level has been addressed. So I think this is everyone knows. I'm just going. So Vedic Unicode and the standards has been bring it out, and Pandalipi Samshodhaka, which is a Unicode based application, has been developed by using Indian languages, by text editing with all Indian languages manuscripts, and along with Grantha as well as Vedic. And we can able to export this one to .aci and as well as .pca also. PCA means for Vedic related content can be saved it as .pca. And we can able to search word wise, phrase wise as well as, and we can adjust the image for readability as well as for printable. You can able to print the manuscripts also, and transliteration of text is also available. So as part of this project, actually so many manuscripts has been collected across the India, like 20 libraries and 30 subjects has been collected, and nearly 12,000 images has been digitized and cropped and available as a tool that we are seeing as a manuscript editor, where it is been project your whatever the manuscript is there, and the scholar can able to edit in their own language, as well as they can able to convert that into another languages also. So suppose if the script is in Devanagari script, you need not type in only Devanagari, you can able to even type in Kannada and other languages also, and you can transliterate to the other language. So along with this, we have multiple texts, because instead of one language, we can able to type 2 to 3 languages. Multilingual texting is also possible. Then Unicode based analytical tools were there, where we can able to preserve manuscripts that we have seen manuscript editor, and Vedic knowledge is able to showcase all Vedic ancient texts in a proper order, like Vedas, Vedangas, like that, and we can able to provide the transliteration facility over there, and one can able to linkage to the concordance, and Heritage portal is having a very good features like browse, searchable, and index things, and along with that analytical tools also has been converted into Unicode format. So this is one which we can able to witness for ancient Indian knowledge base, where we can able to specific book search can be possible, and we can able to go for generic search also. I would like to give one small demonstration before this, because lack of time I cannot able to continue. Last 2 slides.
Can you please wrap it up in the next 2 minutes?
Yes, sir.
Thank you.
This has been designed now, which is friendly for both all the cross platforms as well as cross screens in cross devices also. So you can able to search your text. Yeah, you can able to search your text, and you can able to read in whatever format you want, and similarly you can able to transliterate also, okay, for any other language also. This is possible. And one more thing is we can able to search across because of fastness. Here we can have so many books list are there, whichever we have digitized, all the books are available here for able to search for book wise, and you can go for the next page, okay, and you can do that way here. Next one is phrase search. Just I will like to show. Sorry. See, we can see this text is available Nirukta, Atharvana Veda Samhita, Nirukta text, like that. Across all the texts, wherever this word is appealing, so everything it will search and give you, which will be really very helpful for the scholars to find out where and all it has been referred. So this is the efforts, and I just want to bring with 1 minute, sir. I just want to give what is the future scope, what it is. Yes, sir. So current research is going on with the mean stack and men stack development, and REST APIs as a services, so that no need to reinvent the wheel from another person. They can able to use the service who has been developed from someone else. So such type of technology has come, and we have a public clouds and HPC platforms for petaflops of data storage and processing, as AI models are available almost all. So we can need not mention of that one. And research on STS and STT and text to speech, text to text, and insights on ancient texts are going on as a research field. And NASA claims that why can't the Sanskrit be as a language programming, as a programming language for artificial intelligence. This is one of the things which we can able to think out of the box and then create it. And the future scope, I would like to bring just 2 points which need. Sorry. So the neural methods which we are using for translation from ancient knowledge text to another language, not only that one, I would like to recommend to concentrate on for even to foreign languages also, so that everyone can able to utilize it. The next one is the Sanskrit and voice-based search. Till now we have only text search. Why can't we think as a voice-based? Because it is having prominent and importance for scholars also. And hyperlinking modern science and ancient science as a service. And Vedic analytics. We have stopped morphological analysis to the only Sanskrit. Why can't we think about the Vedic analytics? So conversational bots for Sanskrit, and AI models for manuscriptology, because OCR for rare scripts image search, and Indian and foreign Indian language translation, and restoration of images using AR technology. Right now, whatever images we have, it has been stored. We cannot be able to read, so you can able to restore that one. And crowdsource platform for providing critical editions and translations, because we have very less Vedic scholars and some scholars are available. We can build a platform where everyone can contribute and collate and bring to the insights of each and everyone. And one more, the last but not the least, Sanskrit with the immersive technologies. Why we are not thinking about this one? Because the recreation is possible with the technology solution. So we can think AR, VR, or mixed reality, or gesture recognition, haptics, metaverse, because in olden days we could have seen an astra used to come just like that to the hand, and someone used to show it, because internet is displaying. Is it really capable? Means yes, it is capable. With the metaverse, we can think that one as it, we can able to see that astra in front of us when you say something. With that, I would like to conclude this. Thank you.
Thank you so much. Are there any questions? We'll take one question, please. Just one question.
Everyone are feeling hungry, I think.
Okay.
I request the chair to kindly give his concluding remarks.
Otherwise, no issue. Offline.
Sir, offline I'll take it.
We'll take it offline.
So if the chair would like to make some concluding remarks.
Thank you, everyone. I'll not take too much of time. I think we've had a lot of food for thought already. Dr. Vedavarthi Ramanujam talked about the importance of accents and how these are very important in even preserving knowledge. One thing that comes to my mind as I was hearing his talk is that when we talk about making presentations in public, we usually say that only a part of the information comes from the speech. The rest of it is, the West calls it as body language. But what is packed in that body language is probably a lot of other things like intent and semantics and meanings and other things, which perhaps have always been there. It is just that we have not had an opportunity to represent them in the lexicographic form. It's always been there in voice, and that's the takeaway that I had from this. And I think there are insights that we can take from here, possibly to see how we can do intention analysis and other things maybe when we do this. I was also very happy to hear about the talk by Dr. Nitin Nagaraj, where he talked about data-centric approaches. When I started AI long time ago, people used to talk about the difference between strong AI and weak AI. Strong AI used to be more about starting with a model and then being able to reason with the model. But now we have come to this stage where you want to take data, and using the data you create models with which you can actually do reasoning. But one thing that confronts the problem in this approach is that what people call today as the explainability problem. With model-based reasoning, there was a model based on which you could explain why you are making the inference that you're making. But with some of these large models that we have today, the explainability still remains a challenge, although people have started thinking about it. But I think there is a lot more that can be done in that way. And finally, Dr. Sarita talked about various tools that are available for scholars. When we think about tools, it's not just that we should think about tools for people who want to learn a language from scratch. There are also tools for people who are doing scholarly work, research work, for whom having such tools will help us to be a little bit more efficient, especially things like being able to search. For example, if I take it back to what Dr. Vedavarthi Ramanujam said, would you be able to search even with those accent markers? That is where we need to go to, so that we can actually become more efficient in the way we do research and things like that. I certainly enjoyed all the presentations, and I'm sure all of you did as well. Thank you.
We've had 3 wonderful presentations and also a very succinct summarizing by Sri Ramesh Srinivas Raghavan. In fact, as in Sanskrit there is a saying, Bubhukshitam na pratibhati kinchit. And even the Buddha says you cannot teach philosophy to hungry minds. Whether it is philosophy or whether it's computer science, it becomes difficult after a stage to concentrate when people are hungry. So unfortunately, we have had to cut short the presentations. I apologize for the same because each of them are stalwarts in their areas, and we have had to curtail them. But anyway, we have had a glimpse of what they need to offer. And in fact, it's only the beginning, and we have to spend several years to understand, especially what Vedavarthi Sri Ramanujam sir told. One has to sit in front of the Guru, and then only one has to know what has to be learned. So in Sanskrit also we say Acharya Dhyevahi Sa Vidya Sa Adhishtham Prapat. And also it says in the Upanishads Ananya Prokte Gatiratra Nasti. So only when we sit in front of the Guru and learn, whether it is law or whether it is accounts or whether it is Vedas or whether it is dance or whether it is music. So everything comes from the grace of the Guru in that field. So thank you very much all of you, and I convey my deep sense of gratitude to all of you. So after the felicitations are done, we will proceed for lunch and assemble here once again exactly at 2:30 when we will have a panel discussion. Thank you very much. Now we will do the felicitations. So thank you all of you. Kindly proceed for lunch across the road in the greenhouse, and I request all of you to kindly assemble here at 2:30 exactly.